Hello, and welcome to the Bitcoin.review podcast, where we explore developments and projects with the people who actually make them happen. The show is supported by Pod 2.0, Sat Streaming, and CoinKite. If you're a new listener, I'm NVK. I run CoinKite, where we've been helping people secure their Bitcoins for over a decade. We make the cold card and fun products like the block clock. You can find more information about it on coinkite.com. Hello, and welcome back to the Bitcoin Review. And this is the Housekeeping. It's being recorded after the show, so it's kind of fun because I can opine on the show. It was a great conversation. It was really, really good conversation. I think you're going to get a lot of value of this episode. We really got into the weeds. We start sort of like talking about hardware, sort of like shooting the shit and sort of like talking shop about hardware things, waiting for Craig to come on. And then the show really picks up. We really discuss a lot of attack scenarios, a lot of like physical attacks, a lot of things. Like we talk about Frost, we talk about a lot. It's 2.5 hours long. I think this one is a must listen to. So the Housekeeping here, I want to do a ham radio. So amateur radio panel. So I'm calling for guests to maybe email producer@coinkite.com or one of our ways from our website to contacting us. And I don't know what this episode is going to be exactly, but I do want to do a panel. I want to expose amateur radio to Bitcoiners more. It is infrastructure-less comms. It's very important. So it's in your sovereignty stack, being able to communicate with people without public infrastructure is a huge deal. So let's make a few ham episodes and nerd out on that. Pushing and manipulating radio waves is a superpower. All right, so more audience questions. We're loving these. Even if we don't read them all, they help shape the show. So I do incorporate them sometimes, and they really help us. So keep them coming. Same thing with either the email or the boosts, however you want to get them to us, do get them to us. Yeah, so the previous episode, we really get into the weeds with Dark Skippy and what we believe and what we think about it. It was about an hour of the 2 hours of the last episode was all about Dark Skippy. On this episode, we definitely touch it, but it's not something that we sort of like, we talk about more holistically about like defense of your coins on this episode than just specific to Dark Skippy. I think was good that way. And with that, today we have an awesome panel. I have Mr. odudex from KRUX. Is it KRUX or KRUX? How do you want us to say the project name?
I spell it KRUX.
Okay, that's what I thought.
Yeah.
It's the crux of the problem.
Yes.
What a shitty fucking pun. At least the panel is smiling. I have Lloyd. Hi, Lloyd.
Hey, g'day, NVK. G'day, guys.
I think you have newfound fame.
Yeah, sure. Hopefully. That's what it's all about, right?
That's right. We do it for the lols. And Mr. Rob Hamilton.
Thanks for having me.
And I have Craig coming in a few minutes. He's running a little late, but he's going to join us. So, guys, I've done a few episodes on sort of like signers and wallets. I think it's very nice to get people who are working on the actual projects, to sort of like talk about the state of wallets, the state of signers. I think we're in a much more mature place now in the industry as well. It's a weird time because we have a lot of maturity on signers and wallets, but at the same time, we sort of like there's all this new stuff coming too. So I think that's just like the natural place, like that happens to technology, right? Like it matures a bit, it becomes very good for most people, and then there is like this waves of new advancements, and the pie grows a lot too. So there's like people doing different things for different people, which is kind of cool as well. So anyway, so like I think like maybe we can talk a little bit about DIY FOSS devices. I really wanted to introduce people to odudex from KRUX. I think is a wonderful little project. It's a much needed project, and I love what you guys are doing. So do you want to tell people a little bit about KRUX?
Oh, sure. So KRUX, I'm not the creator of the project. It was created by a GitHub user, very anonymous, called Jeff, and I joined it almost 3 years ago. I was looking to learn about air-gapped transactions and to own a signer, and I thought that this project was very nice. The hardware was very interesting, and I also wanted to learn about MicroPython and RISC-V, which is the core architecture the hardware uses. So at first, I just wanted to have one, and then I researched about the chip that it uses, and I bought a different board than the original used in the project, which was a M5 Stick 5. I bought a one called Mike's Beats, and I thought it would be easy to port it for it, but it was not. It required me to dive into the project. So that's how I got into it and into the developing for it. And it has been evolving a lot. We still have a lot to improve and to make better use of the hardware it already has, and also to make good use of the Mbit, which is the foundation of the core functionality of it.
So for people that don't know, I mean, like this is like off-the-shelf hardware, right? Like it's not custom hardware. And you guys are using the Amigo K210?
Yes, the chip, the microcontroller is K210 from Canaan, which is a manufacturer of ASICs for mining mainly. And it's a very, very powerful chip. We have five or six compatible devices that uses this chip. All of them use this chip.
Why off the shelf?
Because it's easy to use, to get it. Why off the shelf? Some devices require some assembling, soldering, printing 3D cases. It's the case for Mike's Bit. You have to buy an encoder and solder it, and other devices comes ready to use. But they are all development boards, so they have their IOs exposed in connectors to plug sensors and all kind of stuff to play with sensoring and activating stuff.
Right.
So
I mean, like another good part of this is the fact that like you don't have to trust the manufacturer, right? Like you can just like buy off the shelf. So say, I don't know, like Brazil, China, someplace say, no more hardware wallets here, right? Like, good luck sort of like keeping computers away. Like, so I guess you can just buy that, and just use it, right?
yes, these devices are manufactured by different companies. They use the same chip, but we do have plans to port to another chips to make this supply chain issue less like a problem, and maybe have some devices that use Occidental manufactured chips, or maybe even ARM. We love RISC-V, but for the future, the idea is to have a firmware that is more compatible to many devices.
I mean, China loves RISC-V because they don't have to pay licensing fees to ARM. So it's kind of like an interesting incentive set, right? That like the one of the biggest places of like manufacturing in the world prefers this other platform that is licenseless, right? So that could be interesting.
It's very cool. I'm looking at the website. So like there's all these different form factors, which is an interesting concept when you think of like a hardware wallet, like the cold card's a calculator, right? Like the ledger looks like a little bit of a USB stick, like, but there's like all of these, and I'll be honest, like I've seen videos of KRUX on Twitter. I've always seen the one form factor though. I didn't realize that it had all of these different ways that you could dress it up. It's pretty cool.
Yeah. Yeah, I really think that like we're gonna start seeing more, and this is like one of the reasons why I wanted you guys. I actually wanted a few more manufacturers here, but like it becomes too many people and impossible to talk. Like it's nice to see different things and talking about different things. I mean, like Lloyd, you guys are building something that is also very different.
Indeed. Yeah, we're trying to build like a next generation multisig. It actually started out more like we were going to do a community project kind of thing, where Nick and I, who's my co-founder, were working just like on the cryptography part of it, basically for fun. And we eventually found that it was going to be so difficult to do it in a composable way, like something like KRUX, because in order to overcome some of the UX hurdles, let's say with the new cryptographic protocol, we kind of needed a tightly integrated solution. And so we went through like, okay, well, we're going to make it a commercial project. We'll try and sell it as the way of funding this work. And that's where we are now. And so, yeah, we're printing PCBs instead and learning all about that stuff, which is totally new to me.
Yeah, I mean, it's I always commend people who throw the hat in the ring to build custom hardware, because like it's the hardware business is 99% logistics, and then there is the project, and it's brutal, right? It's hard to build custom hardware as a community project. Like I completely understand why you would try to sort of like go the company route. It's too upfront cost, too much capex, right?
It's pretty cheap though. Like you can, like with China, right? You just send them the PCB thing and they just appear, and it's like, okay, great. And then you want to change something next month and they send you the next thing.
Yeah.
So actually, like we haven't found that the hardware part, I mean, we haven't started selling, but like in terms of the prototyping stage,
the prototype is cheap. It's great. Like it's like you send to the fab, there is a website, you upload your Gerber, and then boom, you have a PCB later, right?
Yeah, it's brilliant.
It's like things get nasty more when you start having like parts that you control the supply chain. So as you grow, right, like you don't, it's not the fab that buys your parts. It's like you buy your parts and you send it to the fab, right? Or they buy it in your name, and now you have like because they don't have the parts in volume just available, right? Like you have to like you go to STE and you say, hey, I intend to buy this many this year, right? So what's the price for that, and what's the price for up from that, right? Like, and then they you're in the schedule like manufacturing like of the part, and then they like send you an email, so it's gonna take an extra 32 weeks. And then you're like, oh, so you have to buy parts on aftermarket and pay triple, or to stopgap, and so you have to learn how to stock parts and control the supply chain so they're not fake parts. We actually touched a little bit on fake parts, which was fun on the Livera pod.
Oh yeah,
FTDI, so like and also SignLab, right? So the people who make those USB to serial adapters chips.
Yeah,
it's one of the most like counterfeited parts in the market. It's really funny. One time, FTDI changed their driver to block out the fake parts, and like half of the people who use Windows like why did my USB stop working? And it's because it was all counterfeited parts. It's a fascinating industry. Like it's super like it's an industry that was never designed to be secure. So like you're essentially like fighting upstream, right? Like if you're not using a Java card, which is the only like real thing. And now manufacturers are starting to make better things that are secured and more secure enclaves and making the chips better. But it's still like they all hate the hardware wallets because it embarrasses them all when the hardware wallets are broken by their competitors, and then they have to explain
the ledger Don John comes in and just publishes and something and just wrecks you. Yeah,
I mean, it is remarkable how much money they have spent breaking devices, and it's like super grateful for that. Like I'm pretty sure that Microchip that makes the secure element that a lot of us use hates them. They did improve the chip.
One of the reasons that we choose to use ready-to-use boards, it's because, and I choose that, it's because I worked with hardware for many years, and in Brazil, the struggle is even higher, even bigger, because on top of that, you still have huge taxes, importation taxes, and bureaucracy.
Yes.
So
it's 100% on micros, right?
Yeah, but I had issues with counterfeit components and in products. It's very hard. So I admire you a lot. I kudos to hardware developers. It's a very, very hard job.
It's it's like I kind of want to take a little tangent there on a part, because it's really funny that sometimes I'm gonna just take the tangent. Sometimes people ask, why is your micro SD card so expensive? Your industrial one on the CoinKite store, right? And I'm like, dude, almost all the SD cards that you find, especially the industrial ones on Amazon, are fake. If you buy actually good stock from original supplier, right, and you do quality control on it, it is fascinating how much true SLC memory costs. Why is this micro SD only 512 megabytes or 1 gigabyte? Because it's very expensive memory that lasts 100 years, and it's properly wired. But that's a different tangent there.
I got a tangent on the tangent. It's relevant to KRUX, I guess. Is you guys use an SD card for the firmware in KRUX, or how do you boot it?
No, it's internal flash memory. We can use SD cards just to upgrade it.
Oh, okay, cool.
So, and use as a peripheral to sign transactions and store public data or encrypted mnemonics.
Okay, that sounds better.
Craig finally came in, and he came in right where the hardware nerds were sort of talking shop here. Craig is. It's like a good part of the market of the wallet side, the client side. So we're very grateful that you joined us for this conversation.
Thanks. Good to be here. Sorry I'm late, guys.
No, it's all good, man. Again, we appreciate anybody willing to give an hour or two of their time for a pod that nobody listens to. So guys, we were just talking a little bit of shop, and there was an interesting conversation between Doc Hex, right? For people that don't know, Doc Hex designed the code card with me.
The looks and the brains of the operation.
Yeah, he's the smart one. And there was this fun confusion, and I don't think it's malicious, but there is this I think a lot of people don't know the difference between the OS ware on say a Raspberry Pi or in other sort of projects that are running on top of something, and people don't understand that there's stuff below it. The actual firmware is embedded on the chips. We call that often the bootloader. And a lot of folks don't quite understand that there is a massive sort of broad range of depth you can get in a chip, right? And depending on what part you choose and stuff. And this thread was interesting to me because I thought it was obvious, right, to people that if they read the code of the code card, they would know that we changed the memory vector straight to our opcodes at boot. So on code card, we're it's 100% of the opcodes on the chip are ours, right? There's literally no other code running there. There's just a state machine on the STE. I forgot the part we use now. And essentially when we boot, right, we're essentially calling our own code, right? It's all it does there is just set the flag to go to our opcodes. I believe on KRUX is similar, right? You guys are running right from the bottom of the stack as well.
Yes, we have code that is not written by us for the bootloader. It's a tool called Kaboot, but it's all open source and
right.
So
that's normally what happens with a lot of vendors. Right? If you ask STMicro, they'll give you bootloader code that you can use. A lot of hardware devices, especially people that have been in the market for a while, write their own, right? So Ledger has their own code. I don't know, I can't verify, but I imagine it's their own at this stage. I know, I think the guys from Bitbox also write their own. I think, I can't remember. I think on Trezor is similar. On the Raspberry Pi, you're essentially trusting the stack that's there. You're just running the OS on top. Lloyd, what are you guys using for FrostSnap?
We use the ESP32 C3 at the moment. And that has a first stage bootloader that is totally opaque.
Yes.
We don't know what exactly is happening in there. And then we have a second stage bootloader that we can write ourselves. Though at this stage of development, we've actually been using the default one so far. This concern is like not top of our list, let's say. So the reason is like, so with Frostnap, we're not going for a hardware first approach to security. We're going for like protocol based approach. So we're trying to actually design and engineer it so even if we got a batch of malicious hardware wallets, it wouldn't actually compromise the key generation or even any part of the security. So the signing devices are just used for signing. Now that's like not a strictly guaranteed statement. There are things that the signing devices could deviate from what they're meant to do. But like the key things like generating a malicious key, they can't do that. Like the protocol doesn't allow them to do that. The other thing is like the Dark Skippy kind of attack that we released, they're not able to do that. It's simply not part of the protocol. So we managed to circumvent like these two major attacks. And so someone constructing malicious Frostnaps, certainly a vector would be like the first stage bootloader. Like if I were to create malicious hardware for us, then that's probably what you would do. If you're Espressif or like somewhere, deep in the manufacturing chain for those chips, probably, you would go do something in the first stage bootloader to do some shenanigans there. But I wouldn't know what you would do to actually get money other than some kind of like, ransom attacks where the thing just like stops working stuff. That there's some like lower tier attacks you could do where the thing breaks down and asks you for money or stuff like that. But that's our approach to security.
I guess like for the people that don't know, like the project is not for you to use with like standard Bitcoin wallets that people know now. It's not for your single sig. It's not for your single sig plus passphrase. It's not for standard multisig. You guys are working on a hardware that's specific for Frost, right?
Yeah, it's specifically designed to handle make the protocols really super easy, so that you don't have to ferry things back and forth in just a one-click multi-sig experience. That's that's what we're going for. We're actually trying to get Craig Sparrow wallet working. So it looks like Craig just disappeared, but we're trying to we actually have Sparrow wallet working, so you can actually use Sparrow wallet with it, but it's not like a pure thing. Like you don't plug the devices into Sparrow wallet itself. You will like scan a QR code with your phone with our app on it, and you sign using our phone app. You will sign the transaction. So that we're trying to like integrate with as much power user tools as we can, but we will have to be the one, like our app will have to be the one talking directly to the devices for the foreseeable future, unless things become super standardized around this thing.
So you have like a mobile app that like is middleware can translate between the Frostnap stuff and then Sparrow at the end for that last mile of the signature.
Yeah. Exactly. Yeah.
My only concerns is like I have this love and hate relationship with ESP32. It's like this incredible, amazing, cost-reduced platform that has all the memory in the planet, right? Like for nothing. Like it is absolutely remarkable.
Yeah.
But it's completely unsecure, right? Like, I mean, they offer the secure memory stuff and whatever, but like, it's not hard to like run arbitrary code in memory there.
I mean, in what way? Like, I would say like it's got decent security features for like the price point that it is.
Yeah, exactly. No, that's what I'm saying. It's like it was not designed for security, right? Like it was designed for you to make like
absolutely your toaster,
like a toaster, or like a microwave with a screen, right? Like actually, it wouldn't work because the microwave RF would probably like it's not shielded. So anyway, so the point is like, I like the idea that like you guys are cognizant of the limitations of the hardware platform, right? And you're trying to build around that with like cryptographic protocols, right? That are less dependent on device risk. I think you guys are going to have a lot of fun with USB eventually, but
I'm sure we'll get onto USB, your favorite topic. But yeah, for us, like the ESP32 like has really good Rust support as well. So we get a lot of our security. I mean, some part of our security also is from Rust. Like we actually can't write. If you look at the exploits that have happened in hardware wallets with the USB, not all of them, but a lot of them are like literally like programmers who want to be working on, crypto stuff are now writing a serial protocol and decoding stuff, and they just buffer overflow. They goofed it up because maybe it's their first time doing it and they're not used to this kind of thing. And so with Rust, we actually can't type those things. So we can't actually type the bug that would do that.
No, I think it's going to be more stuff like, you can have malware that just simply puts new firmware on the device, like the ESP32 can be flashed.
There's also that. Yes, that's the other way, right? Yeah, the computer is corrupting the hardware wallet with some kind of flashing thing. So with this, I mean, we're trying to use secure boot, right? So we're trying to avoid this thing by signing our firmware and using the ESP32 bootloader to do the check. I mean, I'm guessing it's going to work, except for unless there are some attacker loading ESP32 stuff that allows them to circumvent it.
I mean, you can get around that. We can chat sort of like off a little bit about that later. But
sure.
We've explored the ESP32 platform before to make devices. We wanted to make a connected wallet, like a.
Yes, I remember.
Yeah.
I remember that. Yeah.
And but it doesn't matter. Like the point is like, there is literally no point in you investing in like making custom secure hardware, like at this stage of the project. Like,
yeah, exactly. We're three people.
Just explore the protocol and see how far the cryptography takes you before you start because if you can get very close to what you need for whatever amount of money people should use for, like, it's great. Like, it's super cheap. Like I saw the little device is beautiful, and the daisy chain, like it's cool.
Yeah, and it's all just with one chip too. So we don't even have these FTDI chips on our thing yet. And it's all like, if you plug it into a phone, the only downside is there's like you connected a JTAG USB debugger unit.
Yeah.
And that's actually what a FrostSnap is at the moment.
Yes.
We'll get better, but yeah, we're three people just starting out. We're trying we're just doing our best with the stuff that's easy and fun. So it's a fun project.
No, exactly. Code card version 1 didn't have buttons. It was very painful to people in Europe with RFI. So we have Craig here. It's like we can talk shop about hardware like for literally ever, but like I feel like one of the biggest gaps right now, it's actually a gap and not a gap at all. I feel like for people who should have Bitcoin now, it's actually quite good and quite easy to have Bitcoin fairly secured, with their cold card and their Sparrow. I'm very confident with that combo. But there is this sort of like narrative, right? Like that we find on Twitter saying that like, it's too hard, the ephemeral grandmother can't use it. How is she going to use Sparrow, right? Like, how is she going to use Cold Card? It's an interesting ephemeral sort of narrative that like, it feels almost like a kind of FUD, or just because people are bored, have nothing else to talk about. So I like to indulge sort of like addressing here and there some of that conversation. And some of the Dark Skippy stuff that, we covered quite a bit, like in detail on the previous list episode for like an hour. And also Livera podcast. And also you guys were on the Livera podcast. Anyways, I feel like it's been sort of talked to death. We can address a bit later in the show if you want to later. But what I loved about that disclosure was the fact that it brought the conversation back on to talk about a better way of doing anti-exfil protocols, right? Because like the current version of it is like really bad for security and really bad for UX, in my opinion, and the opinion of like, quite a few people in the space. So we can get into the weeds of USB, no USB, or, the rounds and all that stuff. But let's just say we want to make it better regardless of where we sit in how we feel about the specific trade-offs, right? It's like we want to make it better, right? And wallets, in my opinion, should talk PSBT. Right? Like they shouldn't talk anything else but PSBT. That should be the only thing that comes in and out of a hardware wallet, right? And I think that really sparked, because we mentioned this like a year or two ago, that we would love to integrate a protocol, if there was one, that used PSBT. And I think that sparked some conversations. HL posted asking if people are interested in talking about it. And listen, we are not cryptographers. We're not academic people. We're just like, we're hardware people who make the bits do things, right? So we prefer if people who are cryptographers and ideally like things get implemented in core, validated on core, and then we sort of like we're downstream from that. So You are an expert on the topic, so like, how could we maybe achieve a protocol like that on PSBT? And Craig, like, like, how do you feel about this whole thing in terms of like UX and security trade-offs from the client perspective?
Yeah, I can talk just a bit about what the protocol should look like. So yeah, we got this problem. Like you said, PSBT should be the only language. And then what really the only language is, the signer is just attaching signatures to the PSBT and
That's
nothing
right.
else, right? That's the whole point. And unfortunately, these signatures, a signer can do that, but unfortunately, they can also send messages out, which is like some capability no one wanted them to have. And it's like very like some people have realized over time, it never really sinks in. Just goes so weird. Like, why can I send a message out through a signature? But you can, just because of the particular signatures that Bitcoin uses. If we were using BLS signatures, for example, it wouldn't exist. But we use signatures which have some kind of randomness involved. So you can put some message inside the signature that is totally covert, which is really, really annoying. And I agree that, first of all, like if you haven't, some wallets have not implemented some protections against this, PSBT based ones. And I certainly don't think that that's the wrong decision, because yeah, they changed the workflow and they changed the way you're meant to use the device. They changed the design of the device, which if not for this problem, would be an excellent design. And so this, there's a strong desire to try to fix this problem in a way that is compatible. It doesn't change what the device really is fundamentally, which is just attaching signatures. And so, we posted some ideas. It turns out, like, because we didn't do much of the pre-research, we were too busy, like, working on our own project and also, making this thing work really well for the demo. We didn't notice that a lot of thought has actually gone into this. And in fact, as far back as 2014, Gregory Maxwell had already posted this, which is a story that happens to you all the time in Bitcoin research.
Of course he did.
Gregory Maxwell already talked about that 10 years ago.
Of course he did. There is a Reddit post somewhere.
Yeah, so Bitcoin talk.
Everything is that.
And so he'd already posted basically what we came to realize is actually the better solution, which is basically, it's kind of just some hashing. It's not too different to BIP32 kind of stuff where you hash the thing and then add it back to itself to get a new key. And so with this randomness, we can sort of disrupt it like that. And then that gets rid of Dark Skippy. But there's also this problem. You can do that, but then you can do what's called rejection sampling. So the hardware wallet could take a bit of a longer time and keep trying until it gets something like embeds a message in there. A few bits of a message. Maybe you could reasonably do like 11 or 12 bits or something. I mean, that's what we were able.
That's a lot.
That's what we were able to do on the Raspberry Pi. Maybe on Coldcard you do a bit less. I guess the Raspberry Pi 0 is a bit.
Good luck with that. The hardware is gonna take a little while.
How long does a Coldcard take to sign? Actually, like a single signature. Did you ever benchmark that?
A single sig that is like reasonable amount of UTXOs is fairly fast, like a few seconds.
I think Jameson has a good blog post.
But like one single signature on one single UTXO, it's like just less than a second or something like that. Or a second.
I think about a second or two. Yeah.
Okay. Well, then this will be fine. So actually, Coldcard is fine then. This because what we would
restriction on memory and speed.
the super slow CPU will actually allow you to notice this attack. Then
that's right.
If they have to keep trying, and so maybe not every signing device. Okay, that's an interesting point because what my extra idea is actually to do some kind of proof of work inside the thing. So maybe like the hash you use is like a slow hash. It means it limits your attempts to kind of like keep choosing these random numbers. And that would sort of guarantee that an honest device will always take the same amount of time per signature. But a malicious device would take like variable amounts of time. And obviously, like with the Coldcard, if it already takes a second, then that's already like slow enough. And then now that makes me question the whole idea because then you've got like different parameters for different signers and maybe it sucks. So maybe we shouldn't do that. And so that's what it would, but that's what it would look like. The PSBT would have some extra like challenge data in there and would get hashed in and the signer would be forced to kind of randomize their signature a bit based on what the PSBT had. And that would just remove the Dark Skippy attack and then would probably limit, depending on how powerful the signer is, to like a few bits per signature. And then, like, yes, the attack is still possible, but we've removed the attack from, like, by far, like, the best class of attack into one where you probably would try the other things. You would probably try the USB weird attack, right? You would probably try to do something else other than this.
I mean, listen, if you manage to put evil firmware on a cold card, you're already like, good luck. You have to break two secure elements and you have to get through around the secure, but might as well just give you a evil device or bang you in the head. Again, this doesn't help against us as the manufacturer, right? Which is like the reason why Dark Skippy is so interesting. Although, you see this, we keep on going back.
It's not meant to be a perfect solution,
exactly.
Right? But it's actually good enough that I wouldn't be bothered to do it. So maybe that's good enough. I mean, that's really the question that's up to the community at this moment is
yes.
Is it, you can lose all your money in a couple of signatures, which it seems bad, but we could make it so this attack probably takes so many signatures and you would have to cluster them together on the blockchain, over multiple transactions, trying to figure out which ones belong to the attack and which ones don't. And then it becomes a whole different kind of thing. To me, at least, is it worth that?
I think the main muddling on this whole sort of thing is that there is a lot of devices now on the market, right? And they all have very distinct secure models and trade-offs. So unfortunately on Twitter and on the drama cycle of this kind of stuff, and a lot of the conversations become very sort of zero sum, right? Because I mean, you guys demonstrated on a Raspberry Pi, right? Which is the least secure platform on this whole sort of option pool here, right? And
Yes.
and it has all the power in the world too, right? So it's here's a full computer, you do whatever you want, right? And then on the other devices, this thing starts to become tighter and tighter and tighter and tighter and tighter and much more difficult to do. And then you have the RFC 6979 plus the Reaper builds and all this stuff, and it becomes sort of adequately good enough until we find something else. But I guess what I want to get to is I think people kind of, especially the people who don't listen to the show, they already get what Dark and Skippy does, and sort of how can we improve this again, right? How can we make the UX better? So because people are adequately secure, in my belief now, with the current options in the market for at least another cycle or two until we come up with better ideas, right?
It depends on the price. I mean, if that's the thing. It changed. Right now, the best attack is to call people up and get them to reset their email or whatever password, and it works. And you get more money like that. And there's a lot of money to be taken like that, as the Minecraft, bros on that Junseth, podcast showed us.
Yeah,
that they, that's the best way to get bitcoins.
Remember the eBay attacks, right, with Trezor and Ledger, where they would pre-populate with a seed, right, and all these people would buy it, and then there's a seed, right? I mean, that's the best, easiest attack that there is, right? Because again, the chances of a manufacturer being evil or having some evil entity in it that tries to sort of stick some stuff in there is very low. It should be dealt with, right? When we design our stuff, our biggest fear was how can we design it so we don't get kidnapped by either bad people or government bad people, right? And make us do something that we don't want to do. That was a legitimate, I don't want to be in a business that I could be kidnapped. So the repo build was kind of how we sort of envisioned that. It's look, the source code is out there, right? And you can load it yourself. And it's very clear to people that if we do something stupid, it's socially, somebody's going to find out very fast that there is something evil in there, right? So that really helps against the kidnap, the manufacturer sort of and we try to minimize the amount of keys that factory have, right? So ideally the factory does not have keys. And we hope that with some of these protocols, eventually we don't have any keys that are related to the manufacturing. Because again, it's very selfish. I don't want to be kidnapped. So Rob, what's your thoughts on that?
Well, I just wanted to circle one step back. Jameson Lopp has a really cool blog post he does every 2 or 3 years where he benchmarks multisig performance. This is now, I think all these devices are using 6979, right? So if you start getting into some sort of proof of work hash grinding to mitigate nonce attacks, this may change. But the baseline right now is if you have 100 inputs, the cold card takes 45 seconds. So it's under a half a second per signature. It ticks up a little bit if you go to 3 or 5 because it's doing more validation right on the whole script construction. All of that to be said, it's very quick right now. And from a consumer experience standpoint, that 1 to 2 seconds is very manageable. So if we're kind of talking about mitigating, if we're talking about extending this proof validation protocol, whether it's building on top of PSBT framework or doing some sort of other round of cryptography to kind of make sure the nonce attacks are mitigated, I think there's some wiggle room in there for it to not even be noticeable to consumers at the end.
I mean, multisig needs to die. Multisig needs to die. I think that's like P2SH multisig must die. That's how I feel about this problem, because it's like, it's extremely powerful, right? Like it does, it's the tool that we have now, and it's very secure. But the amount of trade-offs around it are like really bad. And especially on the hardware, right? Like it's brutal on the hardware. Like, you can get to a point where, especially if you start getting some complex mini script shit that like you want more signing to happen, it just starts to really degrade fast. And then like let alone the issue that we're still like moving back from we moved to sorted multisig, right? Because pre-BIP 67, it was literally hell and people would lose money because of the sorting. So and now because of miniscript, we're moving back to unsorted multisig. So it's a clusterfuck. But the point is this, and one of the reasons why I wanted to have you here and Craig here as well. It's like, how do we move to sane UX, right? Because again, in my belief, the security is good enough, right? And it's actually like 10x what we need for the current state of things. You don't hear people losing money from like commercial hardware wallets, right? Like again, aside from user error, which needs to be resolved.
I was just about to mention the poor man who rolled a 5.
Yes, yeah, exactly. Yeah, or people who plug in 99 zeros because they're lazy, right? Like, aside from like obvious user error, right? Which is, it's our job to try to make it like the least amount, but like, you can't fix full stupid. Like there's a limit to that, right? So like, assuming the security is good enough, like, and we stop sort of like wasting time, because we had 3 years ago, we had the wallet wars, right? Like, and a lot of security was improved. Actual security was improved, like the grifting attacks, the laser fault injection, and like things improved to a degree that's like they're good enough. And so like now that gives us padding time-wise to like, how can we actually make it better, right? Like 100x better, right? And I feel like Frost or something like Frost could make it better. And Craig, like, how do you feel about this from like a client software perspective? Because like you are way more user facing than we are, right? Like ideally, hardware wallet is so boring that a user doesn't touch it, right? Like 99% of the time, all he does is open your software to check their balance, right? Like, and receive more money, all without touching the signer.
Yeah, so I do agree with you. I think that the security is, as you say, probably around 10x better than it needs to be. And we're not seeing any losses from commercial hardware wallets at this time. It's just the other attacks are so much lower. The social attack, or, the kind of somebody just using something which is completely insecure, untested. That's the kind of attack that we see. So, primarily, how do we move forward? Well, I think we move forward by considering the entire user experience. And I think that that's what's often, for me, gets lost when we have these kind of technical discussions about what is the exact approach that we're going to use to secure against this very unlikely threat. We often then have an approach which says, for this particular operation, we're now going to have a user experience which maybe involves 2 rounds of signing, and that is a vastly degraded user experience over what we currently have. Now, I know that we're not putting that forward here, but it's often not considered when I see various proposals being put forward. So that's kind of, I think you have to start with what is the overall user experience, and that includes the security of the device. It includes all of those things, but you can't ignore the actual, what is the usability of this particular process going to be. We can't go and make the hardware signing device take 10 seconds where it takes less than a second for a normal transaction today, because people will think that something's broken. They will just be like, this is, and you'll have like 5 to 10% who will give up halfway through and start pushing buttons, and it won't be a good user experience. So that's where I always start, is how do we improve the security or improve the privacy without making the usability any worse than it is today. And if we can do that, then great. Then we should go ahead and do it. But we shouldn't go, but if we can't, then maybe we need to go back to our toolbox and try and figure out a different approach.
I think you've convinced me the proof of work idea is dumb. Like, it's pretty much just me in my own echo chamber Like it's 100% dumb. Now that I understand also there's like a big variance in the power of chips, which is like obvious in retrospect. I was just thinking about that seed sign the whole time. I'm really dreaming of how to make seed signer good. Okay.
Yeah.
I mean, that's all I think about. I mean, apart from my work on FrostSnap, like what could we do to make seed signer and like be like a really good product because it's all off the shelf parts. There's no checking of the firmware whatsoever. So is it, in theory, possible to build a system like Sparrow? Could it be Sparrow, be secure? The system, as long as your like laptop is secure, no matter how bad the firmware is on the seed signer, like nothing bad can really happen, or the attacks are very difficult to pull off. They're like very low ROI attacks.
Yeah. So like the main issue is, I guess like I've been in hardware a little too long, and like essentially like you just assume all systems are compromised, right? And the more complex they are, the more unsecurable they are, right? And you ask a cryptographer, cryptography is the answer. You ask a hardware guy,
it's the answer.
The answer is hardware. And you ask, but I think we can all like, do we all agree that like, say the computer is gone? It's like, it's fully compromised for an average user. Like, is that like something that everybody agrees?
I would say it like in a more formal way, like whenever you're designing a security system for your personal Bitcoin, you should have like a thought experiment and be like, if your laptop is compromised, then you shouldn't lose any money, right? Or that should be a non-starter for any design, right? That's like what I think. Yeah.
Yeah. This really sort of like brings me back to the early days of Bitcoin, where like essentially like everybody was losing Bitcoin. The RPC didn't have a password, or like your computer gets a virus or whatever. Like if you guys have any firewall on your computers, which I'm sure like within this panel here probably you all do. I mean, you look at the list of shit trying to talk to the internet. It's just like it's literally impossible, right? To even know what the shit is doing. So like it's very difficult to secure a device that like is talking to everything, right? And its job is to talk to everything. I mean, like
websites
are 100 megabytes to display you like 3 lines of text on it. Like, a tweet, it's like 100 megabytes page. Like, so like, and we have this remote execution, right, of code, which is like, WASM and all this shit too. So like, anyway, so like, at least for our premise, we just assume, hey, like the computer is compromised, right? So like, can we de-risk the keys by not having the keys on the computer? And Trezor, or really, I guess like Ledger did it first, really, like just removed from the computer. And there was a huge improvement in security. It's like, the keys are no longer in the computer. And then it's like, wow, like, like you lose a lot less money that way, right? And then like the USB device itself was like not very secured, right? So there's all these other ways for you to take the money out of it. And so we've improved over, 15 years, like things to a degree that we're in now. So I guess like, what are things that like, Craig, do you see from the client side that the hardware signers could do maybe better? This is your turn now to ask for feature requests, right? Like, what can we do to address some of the shortcomings that you see on the process of signing a transaction?
Yeah, it's a tricky one because I really value the fact that signers do very little. That's kind of important, right? We don't want signers doing too much. So, I see signers getting more and more, they let's be honest, they're getting closer to phones.
Yes.
We see the Flex, we see the Stacks, they're coming out, they're starting to look like a little bit like, like some kind of strange phone.
That's for shitcoiners though.
Yeah, sure. But, it's still, it's just a trend that I see.
Yes.
And I think there's going to be pressure on that. And I kind of value the fact that signers actually don't do all that much. So that's my first thing. The second is I think that there's stuff that can be done on the UX side. And by that, I mean, actually the UI, the sort of screen side, to make things appear easier to understand. So, when you're signing a transaction, there's right now quite a lot of text on the screen, and it's fine for us. We understand how Bitcoin works. We can read all of that and we can kind of understand what's going on. But, obviously the more you can see and the more you can depict the transaction that you're making, the more secure it is. So, whatever we might say about using a Raspberry Pi, the fact that you can see the transaction, fully displayed on the screen and the transaction diagram is actually quite a nice feature. But as I say, we have to always bear the caveat that the device gets more complex as you add things like color screens and all of these kind of nice devices. Now, I will always myself err towards a device which is simpler and has more security than one which is complex and shows a nicer screen. So if we can find a way to improve the UI without creating a much more complex device, then I'm all for it. But if we can't, then I'm really rather we stay with a simple device. That's kind of how I sit on it.
I was actually going to bring up, Seed Signer has one of the best UXs of all the wallets, but that's because you have a computer, right? So if you have a full computer, you can draw on the screen, right? Like all the things. As you sort of like get a lower capacity chip, right? That is normally more secure. Like you just have like less memory, for example, right? Like, on Core Code Q, like we have like, it's not quite sprites, but it's practically that, right? Like we don't actually draw on the screen. Like we have like, we just display like the text that is pre-rendered into cells. Like there's cells, like it's not free pixels because again, we're driving the biggest display you could possibly get for SPI. And like it's just impossible to drive anything bigger, and like we can't even like it's very limited. We have a GPU just to blink the cursor, but the funny thing is, but why, right? Like in the request of better UX and sort of like better display of information, right? Like with colors and more graphical, right? You forgo a lot, right? Because now you need either a more powerful chip, a more powerful MCU. You're going to get a lot more holes because it's a much more complex MCU, right? And you're going to have more memory. And then if you want a very secure but more powerful chip, now it costs a lot, right? And you're trying to keep these devices, within say $200 range, right? And this balance, right, of trying to find the best sort of like balance between cost, security, and UX, right? That's the real triangle there. You get back to appliances like Mr. Odudex, where, like a microwave, it's something that everybody has in their homes, and eventually hardware wallets probably be something that everybody has in their homes. There is a limit to what they do in the UX, right? And ideally, you can get to something that's very simple, and it does the job.
Let me push back on this, we can't have nice things. Because I think you can do like cold card security comes from the secure elements, right? So
No.
you cannot, in large part, because you can't get the seed words out as an attacker, right? Without the pin.
No, that's just at rest, right? But there is everything else, right? Like, when you're minimizing like the things that the chip can do, right? Like you have like less ports, you have less. We count how many pins we have left, so we don't have pins left. So that there is one last pin for people to try to do something with it.
But something, like what could they do? The seed words are in the thing.
I mean, like on a Raspberry Pi, you could do LoRa over the pinout. And then you can just stream your seed out of the device over radio. Like they do AM radio. It's true.
This seems like a stretch. Like I would still like see like a cold card with a more powerful chip that did beautiful pictures at a beautiful splash animation. Like I don't think it would really change in my mind the security of the chip. Like that's what I think.
You would increase cost, like to be adequate to like what we believe should be the security model of the device. You'd make a lot more expensive, for example.
But like pixels moving around is worth paying for. Like you get to see, like you get to feel the experience of Bitcoin.
But see, the market doesn't care. Most of the market is like, they buy ledgers with that tiny little screen. That the most sold device right now is the shittiest UX device in the market. Is that tiny fucking little screen with 2 buttons, right? Is the most sold device in all the hardware wallet business, right? The users care about price.
Yes. Here in Brazil, it's definitely the most important factor. So it is that Jade do-it-yourself, it's probably the most used wallet here because it costs $10, and the UI is not that good because the screen is small and you have to use only 2 buttons to navigate. But yet people just buy it because it's cheap, and In price, it's important.
Lloyd, we have this fight internally a lot, right? Like I want to push for better UX and DocX wants to push for more security. And it's always sort of like this battle, right? And then there is the cost realities of parts. And then when you look in the market, I mean, like you look at Big Key, right? They did a lot of research. We talked a lot with them. And, like Block is going to put that thing everywhere on the planet, right? And doesn't have a screen. And it has privacy sort of like trade-offs, right? There you go. That's a big key there. So like,
oh, nice. Yeah.
I guess like, let me digress a little bit. What I think it's missing in the market is one is a non-computer transaction coordinator. Okay. It's something that I always wanted to make, but we don't have the bandwidth to sort of look into. And the other thing is better interop between the hardware signers. So, because see, like you can create a multisig script and quorum with 3 code cards without a computer, right? You choose the MOVN on screen, you set up the thing, you move the SD around, and boom, you have a multisig, and you never touch the computer, right? Like, till this day, I cannot say, just use this other hardware wallet from this other vendor to participate in the quorum so you have multi-vendor. It is absolutely insane how much more security you have by getting like multi-vendor, right? Like you almost get around, say, Dark and Skippy, right? Because now you have to have like 3 manufacturers being evil with that.
Yeah, I would rather have if we got these protections in, something like even not the super duper one, but like this decent one, I would probably recommend to someone like just use 3 cold cards. But then I have to, if we don't have it, then I have to kind of say, well, like technically cold card is now a trusted party. You're trusting the NVK guy. You better study him if you're going to use 3 cold cards for your multi-sig. If you really want the guarantee, nothing bad is going to happen. But if that was in there, then I would be like, hey, listen, there's nothing much that they could do to you by putting malicious software there. So that's where I think that it's maybe kind of interesting from a competitive standpoint within the hardware wallet market, is that like now this advice, like use multiple vendors, doesn't make as much sense because the limitations of what they can do maliciously, is much more limited. It's much less.
I would disagree on that just because there is all the other 50,000 attacks that you can try, right? Like, and like there's 50,000 other things.
People tell me there's 50,000, then I ask for them, and it's like lame. Okay, it's nowhere near like Dark Skippy.
No, but like seriously, like just the fact that you can flash ESP32, right, and put whatever software you want in there, right, after it's been shipped, like in a Amazon warehouse, right, and start shipping people altered version of the firmware, right?
It won't. I mean, but that's the thing. It won't even matter because you can't do anything with it. Like except for ransom. Okay, there is this ransom attack thing, but it's like
no, you can put a completely new firmware in it.
Yeah, but what is it going to do? Like that's the point. Like I'm trying to
anything. It could create like say I fork Jade.
Yeah.
I change it so that it creates like it creates like bad seeds or something.
The bad seed thing. Yes.
Would that be caught by a lot of people? Yes. Right. Like, but it will also have a lot of people that will lose money on that.
That's an awesome point. And this is like the bad seed thing. Like when I actually need to talk about that because this whole like protecting against the Dark Skippy doesn't do anything whatsoever unless you protect against this attack. Like, these are the 2 things that are in the category. And so the fact that people have done non-exfil stuff, it doesn't mean you meet some new guarantee because a user with a laptop and that hardware wallet is still going to be wrecked. Like even if you you need a second computer to check it on, even if you roll your own dice or it doesn't protect because you can't check the XPub that actually gets put onto the computer. You need a second device to check it on. And if we're in a model where we're like saying, please, you buy a hardware wallet, you can't say, please buy a hardware wallet and another one to check it on. It's just like a weird thing to tell people.
People do.
I know some weird people do, but like it's not a thing you can tell everyone.
See, this is the thing. Like, so first up, I can tell you only from our internal numbers, right? So the majority of our users buy more than one cold card. The great majority. Right. And people do check things and they do because we get a lot of support tickets, right? Like, hey, the signature doesn't match because GitHub is retarded on how they do download of the signatures. If you don't right click and save, it breaks the file. So you get there is this very funny little things that really help because this is how people are doing things is when they complain that they can't do the thing. Right? It's one of the best sanity checks because if you ask users if they check signatures, oh yes, they definitely do, right? And it's probably a lie. So like, it's kind of cool that people bump into the problem and then sort of like complain about it.
The other one I've seen before is I ran the deterministic build and the hash of the firmware is different. And then it's like, yeah, because Coldcard didn't give you their private key to replicate the signature, right? It's like stuff like that.
This is a lot of fun time. Like it was about a year or so ago. Like people say, see, Coldcard's deterministic builds don't match. I'm like, yes, those are the signature bytes. Like you can't have those.
Just give me the signature.
And anyways, like it's again, like I think we go back to this idea where it's like I think that the security is adequate. At least, like I believe with our device. There's a couple other devices on the market that I feel the same way about. I don't like some trade-offs in the market. So, for example, the BitKey trade-offs, I don't like it for Bitcoiners. I think it's a fantastic way to get people off the exchanges, right? Like, it's a great first step. If you're already doxed with the exchange, with Cash App and stuff, and like moving to that system that they created, it's amazing. Like, it's like we can onboard a lot of people into that and then move them on to a proper hardware wallet later, right? I don't like PIN servers. I think it was a brilliant cryptographic solution to a problem because the ESP32 is not secure enough. So they figure, hey, we're going to have this blind oracle, right? But now you have a hardware wallet that needs a server. It's not ideal. I think it's very useful to a lot of people. That trade-off versus the price is a huge deal, right? So, but again, it's like, we're all trying to sell things and people sort of like maybe like don't represent things as they should. But like it is a cool cryptographic solution. It's just, I don't think the trade-off is good. So I'm hoping that you guys with FrostSnap offer a better guarantee for the ESP32, for example, through like some of the protocols that you're looking at.
Yeah, I mean, our goal is to make it so you can completely own the thing and it doesn't really matter to the attacker. That's our protection, right? We don't really want attacks against it because we just we don't want it to be possible to do much there. You will always have some basic attacks you can do that trick the user, social attacks, ransoming attacks where the device stops working until you send the attacker money, that stuff like that. But the most devastating attacks where you like the attacker's just stacking up seed words behind the scenes and retiring later on in life, that stuff should not be possible whatsoever with our thing. And Frost makes that very simple. Like it's just you have to do so much complicated stuff for Frost. Like walking over and fixing that problem is nothing whatsoever compared to all the other stuff.
Since we have you here, what kind of advancements have we found to not have to do multiple rounds with the signers?
In Frost, like specifically?
Yeah, so like maybe you pre-share like a list of nonces. Like how do you resolve some of that?
With the signing, or the signing is always 2 rounds, so that's the same, right? So the signing is all the same. It's just except that you have like for example, if you would do it in Sparrow Wallet, the Sparrow Wallet would have to store these like nonces, right, for each signing device. So you would kind of have to have this. I'm registering my Frost signer with the Sparrow Wallet kind of step, right?
So now the client becomes stateful, which is like a trade-off, right? Because before, the magic of the seed and the XPub is that like it truly is magical, right? Like you go in any computer and you download any wallet and you load that XPub and boom, all your money shows up, right? Like it's one of the most amazing things about Bitcoin, right?
It is cool. And this brings that one's broken in Frost because you need to have the nonces up front. Like the signer needs to know those beforehand. So we've done a lot of work like to make that invisible to you. You don't see that anywhere. It's all happening. But yes, you do need to do that. You can do it. And the other thing that's more important than that probably is the key generation. Okay.
Mm-hmm.
And this means you will have like in Sparrow Wallet, instead of saying I'm loading my things from XPub, right? You're going to say, I want to generate a new key. Right? Doesn't have to be it may not have to be plug-in devices. You may actually be able, with some new tricks, to be able to kind of just ferry an SD card. I'm still working on them, but we've got some ideas. I think it can be done.
Make it work with NFC, sir. NFC is the solution to all the problems.
Yes.
Seriously, it is. And it's quite secure too.
I think it can be, a Frost key generation can just be a tap. The protocol, like the specification we're working on now, definitely not. But I think we have some ideas. Like if you piece some academic papers together, you can see how like at least if all the devices like are registered. So you would first register all your signers with the Sparrow Wallet or like Nunchuck or whatever, and they would be like show up in a list, and then you'd be like yes now, and then or you've got them registered in the device, and you say now I want to create a new key. You select all the devices you want to generate a key with, and then you just tap them once. And that's actually should be it. So that would be pretty cool.
Right. On the extreme of the Frost example, we don't even need signers, right? If this protocol becomes like truly sort of like a little bit more bulletproof after the market validates a bit and finds problems, and say a V2 Frost after the V1, I know it's unfinished, but still like like you could just have multiple phones, right, with thresholds, and like your phone, your computer. It's almost like how you can like re-access your iCloud with Apple, right? Like you give shards to like not shards because it's Frost, but like you give parts of your signing to different people, and it's it's not risky, and I always joke that like if Frost is done, like if Frost is or Frost-like thing is the future, we no longer need to be in business.
That's what VCs told. I'm like, VCs, can you please give me some money to do this Frost Snap thing? Like, listen, man, I just want to pay you right now. I've got 3 Android phones. Just let me do it on them. I'm like, no, we need to make a device.
It's funny. Like every time we have a lot of product meetings internally, just like shooting the shit and trying to come up with ideas, right? And like things, because there's like 50 things I want to do. So, but it's really funny because like the closer you get to more complexity, it's like, then just fucking use the phone. It's like you're competing, right? Like in terms of like usability with a $2,000 device that like it's a literal supercomputer faster than your laptop in your hand, right? Like it's very hard to compete with that in terms of UX and expectations of users, because users don't even fucking know about Bitcoin or hardware wallets yet, right? Like in general in the universe. So like for them, what they know is like, look, Twitter works on the phone, Facebook, right? Like that's the expectation for UX. So like,
yeah,
I really feel like eventually we're going to get to a point where you can have just like your ephemeral devices, right? You can have multiple devices and your shards everywhere. And
I have no problem with phones. Like I never fudded phones. We use a phone like very much as part of our design. Like we're using the secure element on the phone to keep encryption keys that can only be released if the user unlocks the phone. So the devices there's no secret information on the devices actually.
I'll FUD the phone for you then. So like,
No, again, before you FUD the phone, the reason like we decided to actually have hardware devices rather than phones is just because like it's a weird proposition to tell people like buy lots of phones if they only have one phone, and like the old phones you can FUD the old phones like for sure, and it's like old cheap Android phones, you can definitely FUD the shit out of them. So we're like, why don't we just package this like small devices, and they're like Legos, right? They're like building blocks of your access policy, and you put them in places. They're cheap, you can get lots of them. And it's super simple like that. And and you don't have to all connect them to the same Wi-Fi network or find a server. Once again, adding a server in is like, another step as a company, like providing that infrastructure. But we'll get there. Like you'll have, we hope to have companies like you're on the board of, of OpenSats, right? And you guys have to manage this Bitcoin. And it'd probably just be quite a lot better if you could each just, have your own phone and like a push notification come in and like, yes, I approve this transfer or whatever. But instead you're like in some, you're using some kind of, collaborative custodian, and you all have to manage your little hardware wallets. Some guy leaves, you got to change the whole multisig because someone's left the board, and like all this kind of friction that comes in there. We'll get there. But we were starting off with this like personal stuff because that's what we wanted. And I didn't want to buy a bunch of phones. Some people do, like they want that right now, but yeah.
Yeah. So like phones are complicated because phones are owned, right? It's just that they're owned by the manufacturer, they're owned by the carrier, right? Like the memory is shared, they have remote access to phones. I always joke that the reason why there is a camera on the front and one on the back is so that the NSA can look at you masturbating, right? And they want to see both sides of the transaction there. They want your face, just so they can post it later and make you do some ransom. No, but seriously. So, but the thing is, again, right? Like it's all trade-offs, right? So, phone as a coordinator, like would be great. Is a phone, especially a walled garden phone like an iPhone, is more secure than your laptop.
Yes.
By a mile. But the problem is you have the phone with you. So you go through the border, they stick a little Pegasus device, boom, all your data is gone, right?
Got to get me one of those.
Yeah, no, they these guys have all the 0 days in all the phones that we're never going to hear about, and they don't talk about it, right? Like it's that there's a huge industry of that. And that's why they like, no, don't even worry about your PIN. Just give me your phone, right? Go ahead, Rob.
Well, it's all trade-offs, right? Because I think to tie it back to the comment Craig was making earlier about user experience, there's something beautiful Grug brain, as you mentioned, NVK, about just like the XPubs and the things exist. And what you're doing, and the reason why that all works, is you're parking that information on chain. And since it sits on chain, you get to have this trade-off of not having to do this off-chain coordination of one making the hardware wallet the coordinator now a state has to hold state of all these nonces and kind of like these multiple rounds for signing. And from my perspective, I think there's a very good chance maybe in 3 to 5 years' time, Frost is the standard for everything, right? But the two things that need to be cleaned up is not just the user experience for these things, but the developer experience to be able to build these tools. There's a reason why Taproot's been around for 5 years and people still aren't like messing around with control blocks and going down script paths very intuitively in most wallets, right? No one's touching the Taproot annex. No one's touching any of this stuff because it technically exists because we kind of threw it in because we could. But all of the developers and people who build tools in the ecosystem aren't really there yet.
Well, it's scary as fuck.
It is.
Right? I mean, like, there is a reason why we haven't merged Edge firmware that has Schnorr and it has Miniscript and all that stuff on Master of Code card, right? Like, because like one of the easiest ways to make something secure is it hasn't been owned, don't change it. Mm-hmm. Like it is amazing.
Of course.
It was one of the most remarkable things. Like, that's why embedded people love making the thing once, shipping into the market, like, and it's just never upgrading again. Like, you even break the fuse of upgrade behind you. Like,
and to that point, my point isn't like being able to just like start ripping and shipping stuff into like the main branch of Cold Card.
Yeah,
it's just that there needs to be more developers building this stuff that are like.
It's hard. It's too hard for most people.
Well, so things like Rust Bitcoin and Bitcoin Dev Kit are like superpowers that I build on top of. You know what I mean? Like, I think getting those kind of like developer experiences that can be ported over to something like Frost, like a Frost Dev Kit, something that can get more people like throwing stuff against the wall, getting more.
We need MicroPython Frost Kit.
Yeah, I mean, I'll take it.
Seriously, it's like I know cryptographers love Rust, right? Like I know you guys are like super into it. It's like it's like the paradise, right? But the problem is that like that's not the embedded world.
Totally.
And I know you guys can compile that shit and stick it in a chip, but it's not the same. You're not dealing with the opcodes of the chip. You're not like it's like you don't want abstractions on like very low resource chips, right? Like part of our bootloader work involved like writing some Fortran. Like
I'm going to be writing the ESP32 bootloader in Rust. By the way, I'm threatening that right now.
Yeah, I know, but
it's going to be hard. I'm going to be one of the first people to do it, but we're going to do it.
It's but that's not a resource limited chip, right? Like that is an extremely powerful chip.
Rust is as fast as anything. Like it's not like the thing. It has no abstractions. There's zero cost abstractions.
No, I understand that. The issue is you need the hardware graybeards to catch up, and they never will. So like the people writing optimizing the chips for and working on sample code for chips and stuff, they're writing the stuff in C, maybe some Python, eventually. And like, that's just what's out there, right? So like we need to meet those devs with the tooling that like they understand, right? It's the same reason why like the web is shit. It's because like you have to like there's only JavaScript devs for the web. So it's like here, build all this shit on NPM everything, right? Like and boom, your money's gone, right?
Just join the master race. Like it's not that hard. Once you do, you'll just be like, why was I ever doing any of this? Like Rust is so much nicer.
To steal a word from the woke people, I think the people on module boards and module solutions are very privileged. I think like once you actually start like getting into your development process and you guys are on V2, you guys are gonna probably look into like more custom solution, right, than ESP32. It'll probably happen. Like it's a natural path of these things, right? And then you guys are gonna be like, oh fuck, like we need C.
I will learn the hard way on that one, NVK. I'm not predicting it. RISC-V, like Rust support is really good. If we're using RISC-V, ARM support is really good. We can compile whatever we want. And if we need to go down to ASM instructions, we can do ASM, hand-rolled ASM. We can do all that.
There you go.
The tooling for Rust is just getting better and better and better. And there's really, now is the time to switch. Just stop coping and just move to Rust.
It's not going to happen. But I always recommend people who write software to go sort of chat with hardware people in other industries outside of Bitcoin too, outside of cryptography, intense sort of markets. Like, go talk to DSP guys, go talk to like people that run like that write a lot of code for Silicon. It's never that simple. But I it'd be great. Maybe Rust is the solution for hardware in the future. I mean, it's not impossible. Because eventually all the old graybeards die, right? So,
but for what it's worth, like this implementation in Frost, Jesse Posner is actually doing the Frost C implementation. So you'll have, I do my own Rust one over here where no one, only a few people come and use it. And, we have a little club, but no one else cares about it. So we'll just be doing, you'll all be using the C code.
Yes.
Written and reviewed by Jesse Posner and, Jonas Nick and Tim Ruffin and all that stuff.
I had them over. We had 2 episodes that were interesting. The libsec P episode and also the Frost episode. We got a little bit in the weeds with some of that stuff.
Yes. So, I guess it's coming to a thing near you. The spec is going really well. Things are coming along. It's still early, but it's really good. They're throwing some innovations in there over the academic papers and mix them in. And I really like them. I think it's really, really high quality people.
Yes.
Working on this. It's just super, super better than anywhere else in any other, not just not cryptocurrency, but cryptography.
Right.
In Bitcoin, we're blessed with some of the best people and they're doing some awesome, awesome work making good Bitcoin goodies. And so I guess, this stuff will be available. I don't know if we can make a Frost dev kit, probably something like that though. Well, there'll be something like that. And, it's coming. And so we'll get to see, I guess I'm interested to see what, you think, Craig, about the UX. Is this key generation protocol something you would put in Sparrow? So where you would go into Sparrow and I want to generate a new key. And then you would have to have some kind of registering of devices. Yes, these devices are going to help me generate the key. And then you click go and then you tap a bunch of things on NFC or you ferry some SD cards, you do some QR codes. And then, you have a key and then you will Sparrow will have to remember nonces, probably in that key generation protocol, you'll get nonces as well. So you don't have to do another thing to get nonces. You'll just get that during the key generation, hundreds and hundreds. So you'll be fine forever. Is that something that you could see happening? Or is it always going to have to be some other software that does that bit and then you can load it into Sparrow after you've done it?
Yeah, I mean, I guess it's hard to say is the best answer I can give it. I mean, it certainly sounds possible from a UX point of view to do all of that. The concern I have always is, is this going to lead to something which is secure? And I do worry about storing the nonces on the coordinator side. I actually had thought the nonces would always be stored on the hardware wallet side.
They're public nonces. It's not secret stuff. So it's public stuff. You can know about it. You can tell they'll eventually end up in the blockchain. So it's not a big problem.
And do you still have the issue that if they get reused, you're going to leak your secret?
Yes.
Yeah, the devices will be in charge of that.
Okay.
Right. So the devices will be in charge of that. So I guess that's an interesting question for NVK. How good do you think could you do a monotonically incrementing counter?
This is funny you brought this up because we always believe signers should have a little bit of state. And there was a huge change between the Trezor ledger thing when we invented Coldcard was this idea that you retain some information there to help the user, right?
Yep.
So if that is checking the addresses, it's not quite stateful because you derive the addresses, but the idea that the wallet checks its own change addresses, for example, right? That was very important to us. And then when we started to get into the multisig development of Coldcard was this idea that you have the script for the multisig in the Coldcard so that you can do some sanity checks. You can make sure that the money doesn't disappear. Again, one of our biggest fears, I guess, is because we came in way back then where multisig was a little bit sort of all over the place, was this idea that again, we want to protect the user from the money going into the ether, right? Again, sorted multisig versus unsorted multisig, for example, right? And having a little bit of that statefulness in the device for multisig creates a very safe environment, right? And then remember when there was a lot of the wallet wars, around the grifting attacks with multisig and all that stuff. And all those things were resolved by, again, storing some statefulness inside the Coldcard. We have good monotonic counters, because the secure elements provide us some. But I don't think that's a good idea because it's very important for me the devices to be disposable, right? So I want a cold card to be in a way that, like, if you forget it in your pocket and you're crossing a border, you just brick me pin on it and boom, toss it in the garbage. You don't, because you don't want to be compelled to produce, right? Like, Bitcoiners think that somehow there is no law against cryptography. Like, cryptography doesn't count in court, right? So if they make you, they're going to hold you in contempt of court until you produce, right? So you need to be able to literally destroy, and then it becomes a different charge, right? But at least, like, you're no longer able to produce. So it changes the dynamic of things. Right? It gives you some agency in this dynamic. So, and devices break. Like, you cannot make a sub $200 electronic device that is like everything proof, right? Like, so it's gonna break.
I'm finding out that the hard way now.
Yeah, and it's gonna die, and you're gonna find QA control issues with ESP32. Like,
yeah.
It's on every industry, right? And the more cheaper more affordable you try to make something, the more trade-offs you make with, like, either power or QA and stuff. And anyways, electronic devices should assume to be broken eventually, right? And that's why you have the metal plates. So, and all these things are stateless, right? In that sense.
For Frost, that's actually fine. Like that. I mean, what you'll do when you break a cold card and you want to replace it with a new cold card, you'll like load your backup onto the new cold card, and then you'll have to like register that with a Sparrow wallet.
Sure.
And then you'll get the nonces and do all that.
Right.
So that's actually that'll be fine.
I think the part that's missing for me to be truly excited about the current state of Frost is that we're missing a way to do this without the rounds and without, like, depending on the wallet to no account. So, like, we kind of go back. I remember on the Frost episode, like, my Grug Bang goes back to deterministic nonces, right? So, like, if we have deterministic nonces with Frost in some different sort of like magical, galaxy brain way, like, then boom, problem resolved. And we don't need to do all this run around to count things.
So we can actually do that. So, like, it can be deterministic. So what you'll do, and actually you don't need to do the counter thing. That's kind of, I realized we figured that out recently, but you just take, right, you have this like first secret, right? That's your seed secret. And maybe it comes from the secure elements or whatever. And then you say, you do an HMAC, a secure HMAC, and you get some like starting one, right? And maybe if you could forget about it, it's actually good. But then you would, like, if you can save that thing somewhere and then, like, you use it as your first nonce, and then the hash of that will be the next one. And so you can actually, just forget about ratchet. So whenever you use one,
make it ephemeral.
Yeah, you make it ephemeral and you ratchet them up so you can never actually reproduce the old one. So you can never reuse it.
Yep.
You don't have to remember stuff. It can be kind of status. You're just like, oh, this is the nonce I'm at right now. This is its number. This is what I'm being asked to sign with. Bam, bam, bam. Like, punch a few holes. Then I forget about them forever by hashing and just keeping around the result somewhere in flash memory, I guess. Something like in flash memory, but maybe encrypted or something with a secure element, something like that. That's kind of how I would see it working. So it's deterministic. It's not like some magical randomness or things need to be updated. Just like one big chunk of these nonces, like a big list of them. You can do 1,000, whatever it is. Send them over to Sparrow.
I'd love to not have to do that. See, like, if we can figure out a way of not doing that, I think it's like, boom, like, it's a winner, right? Because that's like the ultimate UX.
Okay. It's not going to be possible unless we move to BLS signatures. You can like be soft fork.
I know.
Make a soft fork with those BLS signatures because you hate it so much, and I kind of hate it. Like, I'm thinking, like, if I had a time machine, can we just use BLS, guys?
Right.
Instead of all this non-stuff, like Dark Skippy wouldn't exist. Wouldn't have like this non-stuff going around in the seas. Like, is BLS actually that much more risky than Schnorr, given all this stuff about nonces, right?
Yeah.
Yes, like the elliptic curve. Oh, sure, the elliptic curve is much nicer. SecP 256K1, it's much more well tested and whatever. And the BLS is a little bit spicy because it's like this different elliptic curve. But like, when you consider the nonces, is it really that much more risky to move to a different, more fancy elliptic curve that can do these nonce-free signatures?
I doubt we're going to change.
I know we're not, but we can dream, we can hope.
I think, like, for the people who are willing to go multisig, we already do essentially registration, right? It's just you're creating the script between the three devices. So you have to exchange the XBubs, right? And do a round.
Exactly.
So that UX already is a cost we pay, right? So that's already paid UX cost. So, if whatever Frost we end up doing only has that one round at setup, and then the devices can exist geographically distributed and never have to see each other again.
Yeah.
And there is no counting, it's just deterministic. I think it's a winner because now you're back at multisig without the multisig problems.
We can get that, except you have to have like registered the device
Yes.
before.
Yeah.
So it's like, imagine like I've got my devices geographically distributed. Now I want to do a Frost key generation. I can just go tap those and visit them
Yes.
all once and do it.
Done.
But if those devices, like they've never talked to my Sparrow before, I'm going to have to go around to each of them, register them first, and then do it again. So that's like that's as good as we can get it, I think.
I have a question about the key generation. It's a great UX to just tap to generate a key, but I am an entropy maximalist, so I'd like to know, is it possible to put your own entropy to generate the keys?
So you're not in the sense that you can choose your own seed words and then like do that and like verify it. That would be that would be difficult, I think. I mean, possibly if you have why not? I mean, you can say, listen to the device, use this entropy to do the whole key generation to each one of them. You could do it. It's just that like that classic thing, like you need to verify the device is actually using it, and then you need a second device. So
my favorite method is the middle ground, right? So and if you believe the reproducible build promise, right? I think we have it pretty good. So, we essentially take entropy from the TRNG, right? And I think also from the second SE TRNG. And also we let the user input a few dice rolls or a few just click on the screen kind of numbers. But we keep on XORing things, right? So it's like, it's a product of a lot of XORing. I love that because, it's impossible for the hardware to cheat if you can read the code. Like, it's really, really hard. But it's not reproducible. That's the problem, right? Like you can't just go into the other device and do the same and come to the same conclusion as you do with dice. So that's the trade-off there.
If you have to rotate out a Frost device, do you have to redo this? Like everyone has to talk to each other again, all over again to realign everything? Because one of the beauties of Frost is that you can have a 3 of 5, lose one of your keys, rotate that key out, and refresh everything. But that requires everyone to do another round of handshaking, right?
Yes, you require. Like I think we can finesse it into just like, because in that case you've already registered the devices, and the key thing, like the reason this device registration thing is needed is because you need an encryption key for each device already before you start the protocol, because each of those taps is like loading in encrypted stuff for the other guys you're going to tap later. And so I think you can actually do it if you have all that set up and like, I want to remove this device, you should be able to just tap it all once. I'm really hoping this is the case because I don't really want to bring the Frost snaps all back together again just to remove a thing. And I think the papers work out.
That's when you get killed. You know what I mean? Like, that's how you have to think about these things, right? If the quorum is available, if you're able to sign, that's the moment that you can be on, right? Like, that's the risk time.
It's a good way to die, though. Plugging in Frost snaps is really fun.
So, I mean, I really can't wait for you guys to do that over NFC or find a way where there is other vendors to sort of interop on that protocol. I think it would be really cool.
I think it's not imminent, but I think it could come. I mean, I'm just saying it's possible. Like the current protocol we're building in like the specification effort doesn't do this. It actually does some interesting things that is, it actually uses seed, like kind of like a seed. Actually, now that we just mentioned from odudex, like some seed comes in, like, can you put a seed in? Actually, the way the specification is designed is you could have like a single device seed, like for your cold card, right? And you would keep those seed words. And every key you generate, you wouldn't be able to obviously get the key back just from like one seed, like your secret share from one seed on that device, because that key came from like this ceremony, right? But you could decrypt the key from the seed, right? So imagine you've done a bunch of key generations and there's like these encryptions that are maybe kept in Sparrow Wallet, kept in like Google Cloud, kept somewhere, like this big, just a blob of data. And as long as you have the seed words, you can decrypt your share again. And so as long as you keep those seed words around, you can like restore the signer, as long as you have that encryption somewhere. That's the way the spec is designed. That's not the way we use it in FrostSnap. We're not doing that. We're backing up the actual shares.
Right. So
that there is no encryption thing you need to restore, but this specification is like making that available. And I'm interested to know if that's like something people would be interested in. And then you can restore like a full signing device, like all the keys on it from just the seed words, if you have this like these encryptions around somewhere.
So the way we do it, because like people break devices, right? So the way I look about it, like it's like you need two kinds of backups, right? You need operational backup. So that means a more available backup that's encrypted and is a digital backup.
Yeah.
And then you have your non-operational backup, which is like, say, a seed plate, right? So you have your seed on a plate buried somewhere very far from you, right? So, but the operational backup, what I find very cool is that like we essentially like we take the cold card whole memory, right? Like all the settings and all the statefulness of the multisig and the seed, and we encrypt that, right? And we give it some words, and because that was what we found the easiest way to do it, and then you just have an encrypted microSD, right? And it's very strong, and you can keep it as your just way of going back to, the device breaks, your kid throw it in the toilet or something. You can go back to being operational without being at risk by visiting your seed.
Yeah.
Now, another thing that's so in your example, that is still possible, right? Because we can like get that statefulness and that secret from the cold card and put it into the microSD card.
Yeah.
Now, and the other thing we do that I love is that like you can migrate between two devices, right? By doing just a hall diffie between the two, and we move so you can move the secret, without having to worry about in transit, right? Like, the fucking Tempest or whatever. Like these are the things we think about. So you can move and you can clone two devices, right? And then you can, find your better operational sort of security for whatever risk profile of that key setup that you have, right? Because a lot of the conversation when it comes to Bitcoin security, I find that's like, again, it's like stupidly sort of zero sum. It's like people have multiple wallets themselves, right? Like we see this on our users outside of Twitter. It's like, you're going to have your like, signing, like you're going to have one cold card that's just for you to like, I don't know, like pay like, up to $500 sort of suppliers. You're going to have another cold card that's like a little bit more secure that like maybe it's at the bank and like safe deposit box, single sig anyways, but it's like more like your like warm sort of like bank account that has a little bit more on it and people use it so they don't have to like go back, because you never want to touch your very sort of super ultra secure pile, right? That's like multi-sig, multi-travel, multi-crazy, right? So like if you're in a place where you don't have to ever visit that because you have these other operational trade-offs, right? You're in a much better place, right? So it's not like, this is why we have so many features on the wallet, is because people use it differently, right? And I wish the conversation would go that way. And I wish I saw more devices on the market try to address specific uses, as opposed to it's like, we're just as secure as cold card. You know what I mean? Like, it's like, it becomes this fucking like dick measuring contest on Twitter that's retarded.
But no, but listen, I've seen guys with 3 secure elements NVK. Like there's guys with 3 of them. So you need to step up your game.
Right, I know. And like, Lexin is doing very good work, and like the Keystone, right? They have 3 secure elements.
That's what I'm
and it's a funny long story how they evolved from Android to that, and like in Chinese secure elements and Chinese market, and makes this beautiful device for less than $100. Again, trade-offs everywhere, right? But anyways, like I want to see people like work on specific problems, like not just sort of like I carry the baggage, right, of like being early in the market and trying to solve all the problems because there was no solution that addressed most of the problems that I had, right? But now there's a lot of hardware wallets in the market, and they all address a lot of like, it's like, why can't you just like focus on like solve this fucking thing? You know what I mean? Like be the checking account, for example, right? Like it's like yes, like this is a better wallet for you to pay from your computer on your daily, whatever. Like
that's BitKey.
Yeah, exactly, right. But again, trade-offs with privacy and all other issues there. It's just I find it interesting, right? Like I there is this generality that we don't longer need because the market is bigger now.
I think I'd like to mention Sato Chip, who does a similar product to the tap signer. I think they certainly don't intend that to be, where your cold storage goes, but it certainly is a checking account. I think it's definitely trying to do, as you say, target a different market.
Yeah, that's what we did with it. Yeah, I forgot about the tap signer in this conversation. It's like, and a lot of people use that to travel with Nunchuck. So like they put it in their wallet, right? Because then if they get, the bad guys don't know if you have a signer or not. And, like we have a Metro version of it. But it's cool, right? Because you de-risk the phone. with a little tap device that doesn't have a screen, trade-offs, right? And anyways, so like, for example, the NFC part, I find it's like super frustrating because like NFC on phones is hard for devs, right? And it's taking a long time for devs to sort of like catch up. And, we're grateful that like Nunchuck sort of like speared that out. But we need to see more of that because like, QRs, like people don't understand the cost, like in terms of trade-offs that you make to make a QR scanner on a device that costs $200, right? Like people have like cameras that, have processed on the MCU. Like, so you're essentially taking a blob of data into your MCU where the seed is in memory. And like, there's all kinds of risks on that. Very risky. And it costs money, right? Like it's one more complex sort of thing that you're doing on a device that shouldn't be complex, right? So, but the NFC is harder for devs than generating a QR, right? So like we haven't seen, and the phone manufacturers make it fucking awful, right, for the devs to do NFC better too. So, but I am hopeful though that like devs will eventually get there. Maybe Craig will port his wonderful wallet to phones finally, and like help us have one more good wallet on the phone. I want to see that. Like the QR shit is like, it's great. We know how to do it. We now have 2 standards for QRs, but it's not the solution, right? Like it really isn't. Like, you look at where the phone people are going, where the like mainstream market is going is tap, because tap is fucking amazing. And it can be done very securely too. Anyways, so I wanna see that. And like, unfortunately for Craig, you can't have like, tap on computers because the fucking manufacturers don't make laptops that are good with NFC on it yet. Maybe that changes in the future, right?
The one thing that is nice with QR codes is that for sure, because the standard means that this is true, that you can't actually transfer a lot of information. I don't know whether that's true with NFC or not, but I rather like the fact that there's very limited amount of information that I can actually send over a QR code. That is the one advantage to it.
Yeah, well, that's the hope, right? If I have a general purpose camera, right, and I have some malicious software on the computer, I could be displaying other things faster to the device.
They're moving around though. They're like moving QR codes. There's like also high definition. Like I don't know how much data can actually a lot of data can go through there. No,
it's it's limiting on some devices. It's not limiting on other devices, right? Like it's kind of all over the place.
You can like take it from somebody who spent a lot of time figuring out how to get images across.
Yeah,
you can really get very little information across. It is extremely difficult to transfer information over a camera. It just is. It is a limited device.
Well, especially with the potato cameras on laptops, right? Like, I mean, you're dealing. I know this because we have users who go like, it's hard to scan the cold card QR back to Sparrow. I'm like, yes, you have a shitty fucking camera on your laptop. It's like, it's brutal, and like we actually wrote a paper we haven't released, and because it's just gonna confuse people more. Essentially the reasons why like making the QR bigger on the cold card screens are not going to make any difference. Like we have like the whole math behind it, explaining why like just making the QR bigger on screen is not going to change. But maybe we should release that.
No matter how limited the data is, I can still fit your seed words out in 2 signatures, guys.
Well, first you're going to need to make the LED go green. That's your biggest hurdle there. When you can show me how you make the LED go green, then I'll be very concerned.
But that was the funny thing. The seat signer guy got angry because like he could, why didn't you test this on cold card? Like, didn't you do the demo on cold card? Like, I could, how the hell am I going to do that? Like, can you please help me? If you can make the LED go green with my Dark Skippy firmware, then that's absolutely what I would do. Like, absolutely. And I would retire after that as a happy man if I could break that thing and make it the LED go green and have a Dark Skippy attack on cold card and destroy NVK. But it's just really, really impossible. And I don't know. I'm not the hardware hacking guy either. I just know how to,
No, it's like, it's a completely unrealistic attack in that sense, right? Like it would only be a malicious vendor. Like I don't see how you can do it. Like,
well, we could make a cold card that has a green LED. Like,
yeah, exactly. Like you have to make your own hardware essentially, right? Like and ship a fake cold card.
Yes,
and like that's a different class of attack. That might as well just put the fucking seed in there.
Yes.
The thing is, like, what people maybe don't understand when we go full tinfoil, high stakes sort of with hardware is that, like, even the Ledger guys, they were not able to demonstrate seed extraction of a Mark IV.
Yeah.
Like, they were able to say, hey, we've broke this secure element and we broke this other thing, but like they were not able to do that. Like on Mark III, one secure element, they managed to seed extract, right? After 1 year, many hundreds of thousands of dollars later, and a very pissed supplier. But like, like now you have 3 chips you have to break, right? And like you can probably find a way to seed extract, but you can't change the chips to have your own firmware go in it.
Yeah, so they managed to break the 2 secure elements, but actually the funny thing, they couldn't, in tandem with that, like break the STM32, right? That was the main problem with it. Yeah.
And this goes back to the realistic world and defense in depth, right? Like, we have a clear case. We have the security bag, right? We have direct sales. We have a fucking LED light. We have anti-phishing words. Like, we have epoxy. We removed the epoxy because it was pointless. Like, the people that can break the chip can take the epoxy out. So, like, you have the reproducible builds. You have deterministic nonces. You have, like, it's such, like, a huge fucking runaround that it becomes, like, practically impossible to do these attacks. Then, attack the person or, do something else.
But once again, we could manufacture a cold something that looks exactly like a cold card and go around to meetups and sell them. So this is a question I really wanted to ask you.
This is the seed signer attack. They're selling the fucking
seed signer. You can just swap the SD card. Like, it's really the easiest thing in the world. I don't know what. It's a big problem in my opinion. But seed signer aside, why doesn't the cold card do cryptographic like attestation of a genuine check like the other hardware was?
Wait, it does.
No, like how can I plug it into something and it'd be like, yes, this is genuine cold card, or can I put something on the SD card and it like makes a proof that it's a genuine cold card?
So this is again, this is going back to not kidnapped and not making malicious devices, right? We want the burden on the person to make sure they got a good device, because if we start making promises the devices are good, now all the security risk profile changes in terms of like making us corruptible, right? Say, for example, remember when they went after bin Laden, right? Like, they made like a lot of things happen in order to find that guy, right? So they could make us make a evil device that checks signatures now. And that's a huge fucking problem, because then we will invite them to do that. It's the same with, like, say, LavaBit, right? LavaBit was told, you either do this shit against this specific person or we're going to put you in jail. So the guy chose to close down. We don't ever want to be in that position where they could try to make us do this.
Okay, interesting. So you get told by the NSA, like the Ayatollah, these orders for cold cards are actually going to a guy and it's going to the Ayatollah over there to hold Iran's Bitcoin. And then you're going to be like...
They do that.
Okay.
We know they do that. Like, they have this thing called an NSL letter, right? A national security letter. Like, and you can't talk about it. You can't even do canaries anymore, right? Like, and you're fucked. So, like, you're now producing a cryptographically valid thing, right? That is evil. That to me is like, it's like worse than patents. Like, it's like, don't fucking go there. I don't want to be in the business of like being able to produce something that is a lie, right? Because if I am able to do that, that means I'm going to be forced to do that.
That's a very interesting answer.
Like, we become the man in the middle, right? Like, it's horrible. And this is why it attracted me to some of the promises that you're trying to make, right? Cryptographically speaking, about the hardware not being owned, right? It's like, I love this idea of de-risking the people behind the project. Like, last assurances by me. It's like, this is the assurances that this piece of product does by itself as a point solution, right? There's no calling home. Fuck that.
Yeah, interesting. We were going to do a genuine check, but now I'm reconsidering what we want. But I hadn't thought about these national security letters and so on.
I mean, I remember when we were running a Big O before Big O kind of started, the kind of shit that came in the mail from like agencies and shit requesting things, and we made the system so we couldn't know the people. It was a long, convoluted story, but the point is, you get very interesting letters. and the letters keep on amping, and the amount of letters keep on decreasing as the letters increase their potency, right? Like,
Okay.
you don't want to be in that position. It's a very shitty fucking place to be in. That's why I like the multi-vendor multi-sig as well, or multi-vendor solutions, is because like you put less vendors at risk, right? And everybody would give up their shit if it's their kid on the line or their life on the line. And it's like everybody has a line, right, that they will cross and make a lot of damage in the world if they're put in that position, right? Like it's like, I love that line that everybody has a price, right? Like, and the price may not be financial. It may be like, please don't take my hand from me. Anyways, dark thoughts is really where security goes, right? Like it's integral part of what we do as a business. Like, and I mean you guys too, right?
Yeah, no one has done kidnapping protection. Like that is something I actually think about. Like, can we design like hardware such that, if your loved one is not with you, has been disappeared, like you can't sign a transaction. Like something like you need their fingerprint or something.
Right. It's just all of these things turn into key management problems, right? You have to abstract it into a way that Bitcoin understands. So you'd have to have some intermediary that's running basically as an oracle to be like, all right, how you do that? And the drug brain world today is you have a lawyer, and the lawyer holds a key and says, okay, I only do my things if both you and your wife are in the room at the same time.
Yeah.
Right. Like on chain, you can't do that.
Yeah, but then they kidnap the lawyer's kid.
Oh, of course.
No, but this is amazing, right? This is exactly what happens in Brazil all the time, right? So like you have this like condo buildings, right? That are like fancy condo buildings, right? And like they have very decent security, fingerprints to get into the elevator, all the shit, right? You know what they do? They kidnap the kid of the security guard.
Right.
And then the guy opens the door for the bad guys to come into the building. Like, problem resolved. Like,
Oh my word.
This is the world you live in, right? Like, and it's only going to amp up. So like, I highly recommend people when they're doing security thinking, especially people who do a lot of like complex software and stuff, to like go spend 1 year in São Paulo. Like, seriously, like just do that and try to understand the dynamics there. Because like, I really feel like São Paulo is the future of the world in terms of like where it's going to be in terms of security profile for everyone. It's like the deterioration rate of law and order. You have like a disparity of income. So like you have a lot of productive people alongside a lot of like things going wrong, and so and a lot of bad guys that are very productive. so like, how do you incorporate those very sort of practical? How do you prevent the security guard from opening your building and you not being able to sign? Right? Do you have robbers' money? I keep on saying every wallet needs a fucking like decoy pin or a pin that shows robbers' money. Why? You need to have enough to make those guys happy to go away, right?
I think the diversity of key storage, of devices, of methods to sign is good. This is why I think there is not a perfect method. It's good to have NFC, to have QR codes, to have different devices, to have different protocols. So you don't get closed targets. You're better able to disguise your assets, your accounts, so diversity is a key, I believe.
Diversity is a key. I like that one. That you can almost make a t-shirt of that. And it's like, it's very deep line you just said there.
The good diversity and a natural diversity that happens.
Yeah.
And there's like one thing that like, people in security and cryptography don't like security via obscurity, right? Like but reality is closed source projects like often have less public, like, debacles, because it's a lot harder to break something if you don't know where the bugs are, right? Like, while open source software, you can go look at them, right? Like, it's like when you have a new hardware wallet, Lazy Ninja's going to find something, right? Because he can read the code, right? Like, it's like, look, you're doing right here. Right, and you have you don't have asymmetric sort of information there, right? Like a asymmetric dynamic.
I actually studied like the kidnapping problem a bit, like to see, and one thing that actually comes up in real world kidnapping, not Bitcoin kidnapping, but like real world kidnapping, is one really important thing you have as someone who's negotiating with kidnappers or any kind of ransom people is actually technical issues. Like, I have technical issues that makes it very difficult for me to transfer you $1 million right now. It's actually the banking system and the way it works actually makes it hard to pay ransom.
It's on purpose.
Yeah.
It's designed that way. Like, seriously, like, I know banks are bad and we hate banks because we're Bitcoiners and shit, but like, like some of that stuff is designed to prevent people from paying ransom, especially in countries that happens a lot. Like, they simply won't let you take a lot of money out of the bank with a minimum of days.
Yeah. And so you throw these technical issues at the hostage takers, and eventually they like give in, all right, I will take, 100K in a duffel bag because that's all you can get. And then you give them the 100K and you get back what your loved ones. In Bitcoin, I'm a bit worried that like, we're not prepared for this because then there is no limitation. Like, it's too sovereign. And that's why I'm thinking, like, how can even a person, and you're probably the pioneer of this NVK, like features that actually stop you from spending it right away. Like, how can we do that and throw these technical wrenches when people try and do ransoming attacks?
I think the two things are very important, right? Like, super important in this dynamic. One is, you cannot give any symmetry in the information advantage, right? So like, why did we change from just a few trick pins to like infinite trick pin combos, right? It's because like, we want to make sure the attackers cannot know what kind of combo you have of things, right? Like, I'm not saying if you have a gun in your head, then break the thing. It's not that. Like, different people, different problems, right? But just having, for example, a countdown timer.
Yeah.
Right? Like, that the device simply does not let you in with a specific pin, and it shows on screen saying like, listen, 10 hours. Bad guys are on a rush always, right? So, and there is a reason why the bank industry and like security industry for actual physical safe deposit, like not safe deposit, like just safes, right? They have timers. It's like, this shit is not going to open period unless you wait this amount of time, right? Like, it removes a lot of the low hanging fruit. Like you are able to brick things. You're able to plausibly like erase. So for example, you go to the guy like, look, it's not gonna open, take it. But maybe you put a pin that after the time it erases the seed. Like, there's all kinds of trickery because like, when you go read about like cases of people getting kidnapped or shit happening, whatever, like, a lot of times bad guys didn't walk away with things because of trickery, right? Like, that's literally how a lot of these things happen, right? And the other thing is just simply not having capacity to sign on demand, right? So like, for example, we keep on banging on this, don't have your fucking QRC at home because you're going to produce that if you're in distress. If you don't have it, you just don't have it. It's like, I don't have it. Like, there's literally nothing you can do to me that will make it appear, right? And it has to be like plausible, right? The guy has to believe that is true. So if the screen of the device shows something like that, like, you have the advantage, right?
Yeah, it's very stressful. I don't recommend trying to trick people, actually.
Yes.
Like, the better one is like the countdown shit.
Yeah.
That one, it's like, yeah, you want my whole stack? Well, let's sit for 48 hours. But because I have this other one here with a bit less money on it, and you probably won't have to work for the rest of the year on that one. Maybe just take that and like, maybe we'll come back in 48 hours and we'll see if it's unlocked for the other one.
They're very high time preference.
Yep.
Like, they are on the timer, right? Anyways.
Cocaine's a hell of a drug.
That's right. Those guys are on crack a lot of times, like literally on crack, like on purpose, right? So they lose the fear. Anyways, guys, we have like a bunch of questions from the audience. We've been here for literally 2 hours. I don't want to abuse your time. It's just been a lot of fun conversation. Like, this is what we live and breathe inside our company, is like just having these conversations daily internally. It's like, what else can we do? And so I'm really enjoying this. If anybody needs to jump, let me know. It's totally fine. Don't feel pressure to stay, but like, we can continue if you guys want. And what else you guys want to talk about?
Is this where we start making feature requests to Sparrow Wallet?
Yes.
Are we at that episode?
Yes.
Right. This is where Craig starts implementing them while we request them.
That's right.
Yeah. Before the episode launches, it's already merged. No, as a concept, I mean, we were talking about this around the mechanisms for the Dark Skippy stuff. I think in general, PSBT as a spec is underutilized, where you have all these proprietary fields and things that we can put additional data into, right? And one that I think is an interesting concept is I would love to have some kind of relationship between my coordinator and my hardware wallet, where my hardware wallet may actually just like reject a PSBT if it doesn't come from my known coordinator, right? And this is like, I'm spitballing live. I didn't run it by you guys ahead of time, but like if you did some sort of high level just like exchange of like verifying and like key exchange like in that PSBT field, that'd be an interesting way to make sure that like I can actually prove like the supply chain, or at least have an increased confidence of the supply chain of my keys. And you could use these external fields too for all the nonce management. I just think like that's a huge open thing that would reduce rounds of coordination because it's already as part of the same payload with the transaction data in the PSBT. You can kind of just load some extra data to do things like nonce negotiation or do things like verifying that this came from your designated coordinator, right? That can have, obviously it's a warmer key because it's sitting on the coordinator, but you'd at least have some sort of idea of like verifying all this stuff. I just want to throw that out as a general thing, PSBTs, coordinator relationships with hardware wallets, because we have you guys here.
You know, one thing that's always been missing?
What's that?
It's like PSBTs should be encrypted.
That's a good point.
You know, that's something that always bothered me is that like, you know, I have a secret in the hardware wallet already, right? So I can encrypt things. It's amazing.
Right.
If I had a key on, say, Sparrow,
Yeah.
right? That is not a key that holds Bitcoin, right? Like it's a much lower threshold. It's just a privacy key, right? I can now, we now have a way to encrypt the PSBTs back and forth with each other, right?
Totally.
I'd love to see shit like that. BSMS was an early attempt at doing something like that. It didn't like quite go anywhere. We did implement eventually, but like, you know, people didn't really take. But, you know, encrypted PSBTs would be quite nice.
That's a good 2-for-1 too. It has the same encryption key. You know where it came from.
Is it ready yet, Craig?
Yeah. So, I mean, guys, I'm the guy who builds the thing. I'm the product designer, tries to ensure that the kind of UX is still usable, even with all this added wonderful security that we have. But I actually need really smart people like Lloyd to figure out the kind of maths behind it. That's important. So, you know, I can try and do that stuff, but honestly, it's not really my bag.
Yeah, same with us.
Think you really, yeah. So
I think that's a good point because Rodolfo's not going to add a whole like signing protocol, meta protocol on top of PSBTs. If a Galaxy brain hasn't already fully vetted it and been like, okay, this, if you're going to do it, this is the way to do it.
100%.
Like you guys as the product people, it always will come downstream from the Galaxy brain cryptographers.
Which comes downstream from Greg Maxwell 10 years ago.
Which is okay. I'm okay with that. I am a fully believer in gray beards in terms of tech. Like people don't understand that tech comes from gray beards, period. Like that is the trust model of all the tech. That's why airplanes don't fall from the sky, because there's one fucking guy where the internet depends on, and he's on a sailboat. And if he dies today, the internet stops, right? Like this is the trust model we have in the world. It's just that people cannot know that that is the truth. You know, talking about Greg brain, like, I mean, our solution to like, you know, seed de-risking was seed XOR. You know, like that is the level that we want to play at. Anything above that is like, no, you know, go talk to a guy that like writes papers.
Craig, what do you think, like in general, about like more tighter integration between Sparrow and like particular products, right? Because right now Sparrow is very loosely integrated, right? It's all QR codes and like this PSBT stuff. But if you want to start like encrypting PSBTs, you kind of do have to do this thing where you register a hardware wallet and its encryption key, you know, ahead of time. And then you have to sort of, you know, at what point do you go, no, this has to be like a BIP or something? Is that the standard you have? Like, it has to be a BIP? Or do you like say, like, would you work with like a particular hardware wallet manufacturer to like get some new thing in to see how it works? Or like, how does that work for you?
I lean heavily towards standards based. So, you know, it doesn't have to be a BIP. It just has to be a standard of some kind, you know, and there's many different ones. We've got the slips, we've got the blockchain commons guys, they've got their own set of things. We've got, you know, NVK and his team have got their own ones. Barbecue QR is sitting on their site, you know, so long as it's a written up standard, pretty happy with it, that other people can look at, that it's reasonably written. I think that, you know, there's lots of examples of those and they seem to work well. But where it comes to like some poorly documented proprietary thing that the hardware wallet vendor has kind of built for themselves, and then they kind of somebody's reverse engineered it, that's when I start to go, this is not really something I want to be adding. I might have to, because you've got situations like, Ava Chow has done a whole lot of that in order to put HWR together, but that's not really ideal. Like, you don't want to have these kind of black boxes which just kind of do the work, but there's no standards. No one's ever written anything up. And that's not always true for every hot hardware wallet vendor, but it's certainly true for many of them. So that's kind of where I sit. I really just want to see a standard written up somewhere. It doesn't have to be a BIP, but just has to be written down.
There's a lot of bad BIPs as well. So and a lot of BIPs that Core will never implement. But, this is one of the problems that I had with the anti-klepto protocol. It's like convoluted protocol, depends on USB, and sort of it was designed, and it's very proprietary in a way, right? It's open, but it's very specific because they have their own clients, the folks who developed the anti-klepto protocol, right? And it's very easy for us to make an iPhone app and a phone and a computer wallet that is proprietary to CoinKite that talks to Coldcard and is a beautiful UX, right? Like that is the easy part. But we don't want to go there. I don't want the client software on Bitcoin to be part of CoinKite's trust. I want the client to be adversarial to the Coldcard. It's very important to me. It's okay. Rob, you leaving?
Yeah, apologies, everyone. I have to go run.
No. Apologies. It's been 2 hours, dude. I appreciate your time.
Great conversation. Always love going into the deep theory crafting all of this. I think there's a bright future ahead as the dev tools and the user experience keeps on improving. But love the work everyone on the call is doing. I'm definitely going to go check out a KRUX wallet for myself and do a little DIY building time. And Lloyd, I'm a huge fan of what you guys are doing with FrostSnap and MPC, kind of pushing those boundaries. And I got to, do a panel with Nick in Nashville. It was a good conversation. And Craig, you're always just absolutely crushing it. I'll see you again soon enough. And Rodolfo, I've now figured out how to crack the Coldcard. I'm just going to take the LED lights and I'm going to just take out the red one and make it green. Just switch the pins around so it looks like the green pin.
Replace the LED. Replace the LED color.
Yeah, and then I hacked it. Then you're good.
There you go.
Let's see.
It's still going to show a message on screen, but sorry. The rubber guy. Have you seen the rubber with the bomb? It's great.
Oh no! Yes, because I've flashed custom firmware before. I have
some purpose. Yeah,
danger. That's right. It's danger. Love it.
Oh wait, you can actually flash custom firmware. It'll run. It just shows a bomb.
Yeah. You just show a message on screen.
We should have done that. And we should have just edited out the bomb, and then we would have been like, we hacked Coldcard.
You can edit the bomb.
No, I mean in the video, do video editing. In the demo, we could have done the Dark Skippy and just edited out the bomb and just be like, we hacked Coldcard.
That would be hilarious.
Yeah.
That would be hilarious. I can just see the Twitter drama on that. That would be fantastic.
And Photoshop the green to red, so it looks like it's a big green light instead of a red light.
Rob is not going to be able to leave. He's just having too much fun.
I am having too much fun.
We actually did research, we got our smartest minds together in FrostSnap to see if we could make some tape that would change the frequency of the light to make the green red or the red green. And just it didn't work because of we wanted to turn the red green, right? But it didn't work because red is to whatever frequency. It's it needs more energy to go green, and we couldn't add the energy with the tape. It's just the way colors worked out. It's in our culture. If we were in China, the red would be good, and then green would be bad or whatever, and then we could do it, but not in the West.
By the way, I highly recommend people Google the history of blue LEDs. It's one of the most fascinating stories in hardware development, and a dude getting fucked by the company that he worked for, a Japanese guy. It took decades for them to be able to make a blue LED. Very cool story. So yeah, guys, the standards, I don't want people to have the two parts of the setup, right? It's always trying to just de-risk ourselves, right, from having the whole interaction, right? Because if you're using your Trezor ledger with the Trezor client and the ledger client, you're trusting now two parts of the equation. It's often in single sig. It's dangerous, right? I mean, you looked at that ledger shit show when they had somebody replaced that shitcoin protocol on the CDN, and the ledger live downloaded the bad JavaScript from the CDN, and people lost money, right?
Lost shitcoins. Yeah.
Yeah, sure, but the point is it proves it's possible, right? It really is. It's very precarious, right, when things are connected.
It's just it's just programmable money, man. You need to program it with JavaScript that's on the internet. That's what programmable money is. Just get with the program. Attackers program your money.
That's right. It's a program to rug you, right? Craig, and odudex, is there anything else you guys want to bring up on? Think of the whole that we talked about, and imagine somebody listening to this. Is there things we maybe should have mentioned? Is there anything missing? I have some questions from the audience if you guys want to do that. It's been a while. I want to be respectful of your time. So you guys let me know what you want to do.
I'm all good. I can't sleep after talking about Bitcoin with people late at night, so I'll just be awake.
Yeah, we could answer some questions if there is.
Sure. So not Dark and Skippy related. This one. Geographically distributed multisig is probably the best self-custody model today. But specifically, what kinds of places are suitable for storing private key material internationally, or even just away from your home territory? Many people not have high trust family friends that live in different areas, is skeptical of the privacy of bank safety deposit boxes. Then set Sprite 0R. By the way, safe deposit boxes are both amazing and horrible. All you need is a bomb threat call, and boom, in most countries, they can open every single deposit box and take a look inside, and taking a picture of a seed is very easy, right? But SeedXR, that helps, it's tough. And also, I'm sure the panel would not want to get into the details of that because it could also dock some of their setups with their ideas, right? So what do you guys have to say about seed storage?
Yeah, I mean, I think, there's, if you're looking at multisig, you are hopefully doing a situation where, yes, you can have a bomb threat, as you say, but what's the chance of having two bomb threats in two different locations at the same time? That's the kind of thinking you need to have. So I'm a believer in using the kind of commercial solutions that are out there, and they are out there. They do cost money, but, I think when it comes to, storing your wealth, it's worth spending that. If you've been through the process of getting into a professional vault service and what it's like, then you realize this is what security can look like.
These people are serious.
Yeah, it's a different level. I'm not saying it's gonna be 100% in every possible situation, but that's what multisig is for, right? That's why you ensure you have many keys and you make sure you have a decent quorum, so that if one of them becomes lost or compromised for whatever reason, then you have others. So that's kind of what I think. I completely agree. Storing your keys at home is a bad idea.
I think one thing that gets lost, I think, in this conversation, it's a hard truth, I think, to people, is that if you can't afford a hardware wallet, you probably don't have enough Bitcoin that needs a hardware wallet. It's again, that goes back to the use a phone, right? Or use it's unnecessary, right? Why you're going to bother, right? I understand some countries, it's harder to get the hardware wallets. It's there's other problems. It's not zero sum kind of thing, but just as a general rule of thumb, it's if $100 is too much, then maybe it's just you don't have enough assets to store.
Yeah. I mean, use whatever devices you have, store the keys on there. The reality is we're just not seeing thefts from software wallets, from hot wallets at this time. That may change. Who knows?
Well, there was all the Electrum stuff, right?
Yeah, that's true. Those are sort of isolated instances that happen because of some fault in the actual thing. And yeah, I mean, they are valid. But in general, we are seeing a lot of people store a lot of money on hot wallets, and not a lot of thefts are going on. We do have the social engineering attacks, but that's not really, that can occur whether it's a hot wallet or not. So I kind of agree. If buying a hardware wallet seems like too much of a cost, well, then perhaps you're just not at that level yet, and that's kind of okay. That's not a bad thing, really. It may happen in future. You have to, when you get to that point, you'll be worried enough, you'll be lying awake at night, and then you'll feel the need. And when that isn't enough, then you'll move to multisig. It's just kind of solving the needs at different levels, depending on what your security requirements are.
Yeah.
I think the questioner asked, he mentioned his situation, or she mentioned his situation, didn't have many family members. One thing you can do is just reproduce and like wait 18 years and then kick them out of the house, and then you'll have some. Then you go reproduce. That gives you family members also multiple places to store your keys and a trust network. It comes recommended. It's like with Satoshi did this, so we all have to do this as well. But we have Greg Maxwell recommends it too, I'm sure. The thing is, you have to kind of like your seed words and your security devices, your sign devices are kind of like Legos for building your security access policy to your keys. And then you have to, the way you build the space you have to build your Legos is those locations you have like exclusive access to that can be via secrecy because you're the only one who knows. Like you could bury it in a public park or whatever, as long as you understand the geology of the place. So that things, how meteorology and how the mudslides don't happen, it gets disappeared. Usually you do it in some kind of physical access, exclusive physical access to some place, in addition to some kind of secrecy.
Yep.
And you just have to work with what you've got, basically. You should try, if it's your life savings, and a lot of times it is people's life savings now in Bitcoin, which I think is great. But you probably don't want to be able to spend your life savings in 2 minutes.
Yeah, there is like, you can't drive without learning how to drive, right? So that's number one. It's like you have, like, if you want to do Bitcoin self-custody, you need to learn. Like this ephemeral grandmother is a terrible fucking idea because if you have to make it so easy that you don't have to understand what the fuck is going on, you're gonna probably get like scammed. You're gonna say the seed over the phone, right? Like you have to understand and I think we do a disservice sometimes making things too easy, right? Because then we're removing all the agency from the person too, right? It's not a great thing, even though we all want grandmothers who have a lot of Bitcoin for some reason. And like, you have to look into estate concerns. We did an episode about it. It's like, it's not that simple. The law doesn't give a fuck about cryptography. It's not possession. It's like, you have to have rights to title and, go learn that depending on the country you're in. It's very different. Yeah, it's tricky. There's no easy answers. It's like it's new tech, and it's full responsibility.
Yes, and investing money is not enough. It doesn't matter if you buy fancy equipment or you got to study, you got to invest time to. There is no miracle.
If you're not willing, buy the ETF.
Scaling Bitcoin.
For some people, it's just fuck it, buy the ETF.
It's suitable for many people.
That's the stomach you have for. All right. The next question. How have best practice evolved as migrate from ECDSA to Schnorr in terms of interactivity, uptime, then therefore reshapes UX? Concurrent sessions, nonce counters, etc. Vivek. Of course it was Vivek. I think we discussed a lot of this earlier in the we did a whole rundown, right?
Yeah. Schnorr and ECDSA is no different, but Frost is different.
Yes.
Than everything else, yeah.
All right, so possibly Darkscape related. Okay, so are you aware of any known attack methods to add malicious code to an SD card with or without any physical access to it, like some type of radio frequency attack? I do, by Kid Warp. So there was this researcher a few years ago. He did a CVE on doing Tempest on hardware wallet screens, right? Because you have a signal line there that draws pixels on screens. And this actually goes back to the original Tempest from way back when CRT screens that you could read from another house across the street. It could read somebody's fucking screen because of the RF that CRT produces. So this guy figured out how to read that from like the LCDs that hardware wallets use. Very reasonable attack with enough, with a little bit of like radio work, you can totally do this from a neighbor house or a condo or a hotel. So the solution, at least for us, was to just add a lot of like noise. That's why you see the little squiggly lines when we're drawing secrets on screen. And it just means we're adding entropy and we're randomly drawing on screen, right? I think a lot of hardware wallets found like similar solutions to that. And it is a viable attack. We've seen like attacks in hotels. Hotels are the hot spot for a lot of this stuff because it's an uncontrolled environment, right?
Well, you've seen people doing this radio frequency, like not in the context of Bitcoin, but in like some other espionage context.
It's a thing. Yeah, absolutely. It's a thing. And there's a reason why, state actors, for example, when they have meetings, they have a Faraday cage with like comms that are secured and all kinds of shit. Because you can listen to somebody in a room by pointing a laser at the glass and seeing the glass vibrate, right? So you can have a computer listen to you clicking on the keys of a hardware wallet. That's why we allow you to randomize the input of the pin, right? Like all these attacks are like, listen, some of these are a little bit more convoluted, right? But they're very realistic, right? Like the evil maid type attacks and sort of this stuff is very realistic. And as the stakes increase, price goes up, there's going to be a lot more interest in doing these things, right? Anyways.
One thing with the SD card, there are these these write once SD cards you can get. So if you were like seriously using a seed signer, I would probably take like one of the write once SD cards, like write the firmware once, like do a mark on the SD card and just check it each time before you put it in. And then you don't even have to do this thing where you take it out, right? And then because then you want statelessness because it can actually not be written again.
But then you have the QR at home, right, to loading the seed.
Yeah, I mean, that problem we're not going to solve here. But yes, but insofar as you can like get it to the local optimum of design, doing your DIY thing, I think the investing in the write once SD cards, like where they use NOR flash or something, and it can't be erased, is like a nice trick.
People have put FPGAs and things on an SD card form factor. So it is possible to make an Evo micro SD card but like it has not been demonstrated to us, for example, that was possible with our device. So like that's as far as I have like.
What's it going to do? This FPGA is going to like, I don't know, fuzz your implementation of the.
Exactly, right. It could try to do something, right? But it's fairly defended. So like it doesn't concern me too much. And you can always like buy piles of micro SD cards and dispose them after use too. There's all kinds of things you can do.
Yeah.
We thought about putting a secure element on a micro SD card shape, so you could stick it in. So you have a read, you essentially have a seed that's removable from the device and leverages the micro SD port. We actually made a prototype of that. But again, it's like the rabbit hole is deep, and is there a market for that? It's just whatever. Just encrypt a seed in there, micro SD card, you're good to go. But everything is an attack vector. Explain, if you could, why the anti-exfil protocols don't work air gap. No, it does work. We've talked about that.
But the existing ones, the ones you don't like, they don't work air gap very well because it's 3-round protocol.
Yes,
it's like you have to go back and forth and back again. That's out of the question. It makes the user experience much worse than it would be for just a normal signing if you were to do that.
Ask your Steam panel what the solution to all these problems is and why it is Miniscript. CoinJoin Chris. Blue Eyes, the Blue Eye Finance. These are the problems with Miniscript. Dark Skippy related. How does the seed leak stuff work? So we already talked about all that. I'd love to hear some of you favorite ways that Pawn hardware signer can steal funds that are not involved Dark Skippy or similar. Reardon. I mean, again, USB is a wonderful fucking shithole. That there's a million things you can do over USB. It's most hardware is not defended appropriately, adequately for a USB. One thing people don't know is that a lot of the hardware devices in the market, the same UART access for you to program the device is how you then turn into a USB connection. It's the same pathway. It's the same chip. So it's very dangerous, because bugs, like it's not even malicious or anything. It's like, you might have a bug and boom, your USB is open, dump seed, you can replace the firmware. There's all kinds of shit you can do, man. It's fucking USB. Like,
okay, let me talk in defense of USB. So that we have, you can though, if you're careful, use a chip that just does the serial bridge and don't wire it to your MCU in a way that can do anything other than write to UART.
That's a fallacy. Because, you're going to use that, because you're going to use that. First of all, that chip could be, that's what FTDI does and Scilab do, right? Those, the biggest two. Those are the most counterfeited chips in the market.
Yeah, but it doesn't matter if it's counterfeited. I mean, if it's counterfeited, whatever. It doesn't do anything. It has nothing it can do other than write ones and zeros to your pins.
How do you load the firmware into the device?
Some other method, like using the JTAG and then disabling JTAG.
So on the board, right?
Yeah, directly onto JTAG pins of the device, right? So instead of, and you can also just disable that thing. Like you can disable that feature later on. Like you can just make it so you flash it in the factory, then you disable all that USB service area.
This is the problem. The trusting of the disabling is the concern.
Nah, it's no more trusting than whatever else you're trusting them to do, I would say.
Oh no, it absolutely is. It's very dangerous. Very, very dangerous. Like, well, look at the Jade, right? I mean, you can dump the memory.
That I think that's part of. I mean, that's a decision that they've made to do. But I'm just saying you don't have to.
Okay.
You don't have to allow that. You can use the same hardware setup if you just say, hey, no one's allowed to flash this thing. They want people to be able to flash it later on, so that's why they left the flashing open. And you think that you're very scared of the flashing, which I mean, it sounds like something like I'm plugging it into a laptop. I don't really want the laptop to have the capability to flash memory of that thing. So I do share your concern on that one, even though it has, you'll be using Secure Boot and the flashing of a J will not allow it to actually run anything.
You're jumping into some new knowledge as you try to understand the Secure Boot of ESP32 a little deeper. I'll leave it at that. Like, don't worry, I'm not going to pound into it on this. It's too late in the 2 hours for us to talk about that. But
okay, but then some other things, maybe like you can just like look at some other attacks. Okay, so the number one attack that will always work and you can never really get rid of is the ransom attack, where the device just says, "Oh yeah, you sign a transaction and like the change output was like over a Bitcoin," and the device just says, "All right, I'm never signing again until you show me proof that you've paid the attacker like X amount of Bitcoin, and then I'll like let you the sign again." And also, the device gives you fake seed words.
Yeah, that's the best one. Craig needs to go, so just a sec.
Okay.
Craig, thank you so much for coming. Like, I appreciate it. And this was a very fun conversation. If you want to stick around and just listen, or if you really need to go, whatever, just thank you so much.
Cool. Awesome to be here, guys. Great to chat. Chat soon.
Take care.
See you, Craig.
Yeah.
All right, guys. You know what? Maybe we should do another episode where we just talk about like holes. Like we just sort of spend 2 hours talking about like a history of attacks and things.
That would be very educational.
It would be very educational. It's a lot of fun, guys.
Me too.
You know what? Like, let's wrap this up. So, listen, thank you so much for coming. If you have any final thoughts, feel free to leave them. So, Dudex, any final words, sir?
About security, I think this race will never end. There will always be newer attacks and newer solutions to defend from them. So let's keep moving and fighting, and that's it. And this is about the main thing of the future of hardware signers. I'm anxious to learn about the new things being developed, such as Frost, and that's it.
Hey, listen, thank you so much. I absolutely love your project. I feel like it really sort of like addresses a lot of the need for DIY FOSS, but in a way that's like secure and makes like interesting trade-offs and like, it's really trying to work on the embedded stuff. And, you guys are really sort of trying to do a lot of things there. The seed is encrypted in the device. Like, there's just a lot of like good stuff. And I'm happy you guys are working with OpenSats as well. You guys are in outside of North America, working on outside of North American people's problems, being from there, and not sort of just saying from here that, people in this developing country needs stuff, right? Like, because, no, it's like, it's real. And I appreciate that. Thank you so much for coming.
Thank you for having me. Thank you for all your support to our project and public support, bringing many people to join us in this. It's like an open club where we try new things, and it's having a lot of fun. So people are invited to join it again, join it too. So thank you for having me.
Thank you, sir. Lloyd, any final words, sir?
But I'd like to congratulate anyone that made it this far. Like, if you're still listening, you're going to make it. Let's just say that you're definitely going to make it. Don't give your seed words over the phone. You'll probably be fine. We'll see what the future holds for us. And I'm really excited. And these kind of conversations are great, NVK. I really enjoyed this. So thank you.
No, thank you. Thank you so much. Listen, it's, I love what you guys are doing too. It's different for, like finally different stuff, like, different trade-offs, different packaging. Like we can argue about hardware, we can argue about like, all kinds of things for literally ever. I love that you guys are doing research on security and like it's really cool. It's really nice to see. I appreciate the fact that, like you're 2.5 hours, with nobody listening to. That's the running joke. There's a lot of people that love it.
I'm getting a lot of value out of this. If someone is listening and getting value, then they're a legend. But like, I really enjoyed this conversation because, yeah, I mean, we bounce ideas like you guys are bouncing ideas internally in CoinKite. We have ideas internally and we come up with our own conclusions, and we have certain strong personalities and conclusions we come to. But it's fun to test them out in public, right? It's fun to test out my ESP32 defense against NVK. Is enjoyable.
That's how we progress, right? Like, it's like, like there is like responsible disclosure, which was amazing how you guys did with the paper. I think was very tasteful how the whole thing worked out. We've been part of disclosures that were not responsible before. We've seen things, and everybody disagrees when it comes to security. That's part of security, right? Like, and this is the party. It's like, welcome to the party, pal meme, right? Like, it's like you guys are harder to manufacture now, right? Like, I think it's super cool. And again, thank you so much, guys. Have a wonderful day, and just make sure you upload. And I'm going to stop recording now. Thanks for listening. For more resources, check the show notes. We put a lot of effort into them. And remember, we don't have a crystal ball, so let us know about your project. Visit bitcoin.review to find out how to get in touch.